to order. And without objection, the chair is authorized to declare recess at any time. Pursuant to House Resolution 8, today the committee meeting is virtual. I want to announce a couple of reminders to the members about the conduct of the remote hearing. First, members should keep their video feed on as long as they are present in the hearing, and members are responsible for their own microphones. Please also keep your microphones muted until you are speaking. And finally, if members have documents they wish to submit to the record, please email them to the committee clerk, whose email address was circulated just prior to the meeting. Good morning and welcome to the first climate change hearing of the Science, Space, and Technology Committee and the 117th Congress. I want to thank our esteemed panel for joining us today. Our communities are already dealing with very clear and present danger of climate change impacts. NOAA found that 2020 set a new record of 22 weather and climate disasters that each exceeded $1 billion in damages. The unprecedented year included the most active Atlantic hurricane season, multiple damaging severe wind events across the Midwest, and a record-setting wildfire season in the West. In my own state of Texas, we've seen the impacts of extreme weather over the past year. As this committee discussed last Congress, many of these devastating impacts fall hardest on our most vulnerable populations. We know that in many cases, climate change is making these weather and climate events more intense and more frequent. Our ability to predict extreme events and our confidence in attributing some of them to climate change has improved over the time. With that knowledge, we need to act to both mitigate and adapt to these impacts before it's too late. Climate solutions are built on a foundation of robust, sustained, and long-term investment in climate science, observations, and modeling. In addition, we need to develop climate solutions that take into consideration multiple disciplines, not only the physical and natural sciences, but the social sciences as well. Finally, we need to ensure that these disadvantaged communities that are hit first, worst, and hardest by the impact of the climate change are at the table when potential solutions are being developed and implemented. Addressing the climate crisis is a unique opportunity to help America back to work. Given the economic downturn our country has faced due to the COVID-19 pandemic, it is vital that Congress prioritize federal investments that will provide well-paying and long-lasting jobs for Americans across the country. Last Congress, the committee had a great success in moving 15 bipartisan energy innovation bills in the Energy Act of 2020 that were enacted into law. While this was a significant accomplishment, our work is not done, and I hope to build off this strong bipartisan work. This hearing is simply the first step in our committee's effort to address the climate crisis in the 117th Congress. I'm looking forward to working with our subcommittee leadership and committee members on both sides of the aisle to develop and move strong bipartisan and impactful legislation to address the climate crisis and create actionable climate solutions. We have much to consider today, and I again want to thank our witnesses for participating in the hearing, and I now yield to Mr. Lucas for his statement.
Thank you, Chairwoman Johnson. And as we kick off our first climate-focused hearing this year, I'd like to reflect quickly on the milestone energy legislation we passed last year. Together, we were able to pass the first update to federal energy policy in over a decade in the last Congress. and that is in no small part due to your leadership and willingness to hold good faith negotiations with this side of the aisle. The Energy Act of 2020 includes more than a dozen bills from our committee and focuses on competitive and innovative clean energy solutions driven by basic and early stage research. It's a prime example of the work this committee is uniquely positioned to do to combat climate change and strengthen American energy. The simple truth is this: America's clean energy future is driven by innovation, not by mandates. It's our job to support that innovation and invest in the basic research that will provide the springboard for new clean energy technologies. One of our witnesses today, Dr. Zeke, Housefather, points out that the U.S. is in a unique position right now to accelerate research, development, and deployment of low carbon technologies across all sectors of the American economy. Through targeted investment and demonstration of federal research, we can develop direct air carbon capture, small modular nuclear reactors, and other technologies that will completely transform our energy production to a cleaner, more efficient industry, unrecognizable from a century ago. And we can do this without raising energy prices and hurting American consumers. I worry that the cost of making immediate and drastic changes to our energy portfolio are being ignored by some of my friends. Imposing strict mandates is going to make it harder for our businesses to compete with China, whose greenhouse gas emissions continue to grow. But we have hard evidence that investing in innovation allows us to cut our emissions while growing our economy. For instance, using discoveries at our national labs to improve hydraulic fracturing technology has given us more access to clean natural gas. That in turn has played a large role in the 10% decline in US greenhouse gas emissions between 2005 and 2018. And in that same period, our economy grew by 25%. Higher costs also hurt American families, and rural households are especially vulnerable to energy price swings. We have to be mindful of the many communities whose economies depend on our current energy infrastructure. So I want to be very clear. Abandoning our current energy infrastructure has a regional impact, is the regional impact of climate change. Just like moving away from rising sea levels on the coast, entire families would be displaced if we move too quickly to prohibit fossil fuel use. Fossil fuels are not the enemy. They are the most reliable form of energy in the US and will continue to be a large part of our energy portfolio. Our focus shouldn't be on eliminating fossil fuels, but on making their production and use cleaner and more efficient. We're already making headway. According to the International Energy Agency and the Breakthrough Institute, it's quite possible that global CO2 emissions from fossil fuels peaked last year in 2019. We know what we need to do from here. Invest in the tools needed to reduce greenhouse gas emissions, like advanced nuclear, carbon capture, and greater energy storage capacity to make renewables more reliable. If we want to make real progress addressing climate change, we need to move forward with these bipartisan priorities. We've taken the first step with the Energy Act, and I look forward to working together on more practical clean energy solutions. Thank you, Madam Chair, and I yield back the balance of my time.
Thank you, Mr. Lucas. Now, if there are members who wish to submit additional opening statements, your statements will be added to the record at this point. And now I'd like to introduce our witnesses. Our first witness is Dr. Michael Oppenheimer. Dr. Oppenheimer is the Albert G. Milbank Professor of Geosciences and International Affairs at Princeton University, where he has served since 2002. He also directs the Center for Policy Research on Energy and the Environment at Princeton. His research focuses on projecting sea level rise, coastal flooding, and resultant risk to coastal communities, as well as adaptation and other responses to climate change, such as migration. He has been involved in the development of Intergovernmental Panel on Climate Change, the IPCC, assessment research reports since 1990, The IPCC Special Report on Oceans and Cryosphere is Changing Climate and the upcoming 6th assessment report. Our next witness is Dr. Zeke Housefather. Dr. Housefather is the Director of Climate and Energy at the Breakthrough Institute, an environmental think tank in Oakland, California. He is a climate scientist and energy systems analyst whose research currently focuses on observational temperature records, climate models, and mitigation technologies. He also serves as a research scientist at Berkeley Earth and is a contributing author to the upcoming IPCC 6th assessment report. He previously spent a decade as a data scientist in the clean technology sector, including co-founding the Efficiency 2.0, an energy efficiency software company. Our third witness is Dr. Noah Diffenbaugh. Dr. Diffenbaugh is the Kara J. Foundation Professor in the School of Earth, Energy, and Environmental Sciences at Stanford University. He is also the Kimmelman Family Senior Fellow at Stanford's Woods Institute for the Environment. He researches the climate system, including how regional and local conditions, such as extreme weather, impact people and ecosystems. He is an elected fellow of the American Geophysics Union. He has been a lead author for a number of scientific assessments, including the IPCC 5th Assessment Report and the California Climate Safe Infrastructure Working Group. Our final witness is Dr. Paula Bontemp. Dr. Bontemp is the Dean of the Graduate School of Oceanography at the University of Rhode Island, where she oversees academic, research, and outreach activities. Prior to this role, she was acting Deputy Director of NASA's Earth Science Division within the Science Mission Directorate, where she provided leadership, strategic direction, and management of the agency's Earth Science portfolio. Overall, she spent nearly 2 decades at NASA as a physical scientist and program manager in the biological oceanography. Her scientific interests include studying the Earth system, ocean sensors and technology, and diversity and equity initiatives in STEM. And now let me just say that our witnesses need to know that each of them have 5 minutes for the spoken testimony, and the written testimony will be included in the record for the hearing. When all of you have completed your spoken testimony, we will begin questions. Each member will have 5 minutes to question the panel. So now we will start with Dr. Oppenheimer.
Thank you, Chairwoman Johnson. I'd also like to thank the members of this committee for inviting me to testify at today's hearing. The views expressed in this testimony are, of course, my own. While a sharp global reduction of carbon dioxide and other greenhouse gases with the aim of achieving net zero emissions by mid-century is necessary, it will not be sufficient to protect people and places unless accompanied by an aggressive program to adapt to unavoidable climate changes occurring now and yet to occur in the near future. Even today, the U.S. is falling short, particularly in protecting the most vulnerable segments of its population. I'll focus first on sea level, which is rising due to warming and also accelerating due to melting and disintegration of the edges of the Greenland and Antarctic ice sheets. The largest uncertainty in projecting sea level rise is how fast this process will eat into the ice that's further inland, and how much sea level rise is inevitable by 2100, even if the world meets the long-term objective of the Paris Agreement. On the other hand, we have a pretty clear picture of sea level rise through the year 2050, when uncertainties are not large, providing a sound basis for coastal planning and implementation of defenses. Sea level rise is already resulting in a radical shortening of the return time for what have in the past been rare events. Even on a pathway to 2 degrees Celsius warming of global warming, that is about 3.6 degrees Fahrenheit, the Paris target, the historical once per century flood level at many U.S. locations is expected to recur every year or more often by 2050. The list of such locations includes Savannah, Jacksonville, Miami, Los Angeles, San Diego, and Honolulu, among others. Different areas will be affected to different extents. How to respond needs to be decided well before 2050, essentially right now in many places, because building protection or implementing planned retreat to higher ground can take decades. Recent experience with a growing list of deadly climate disasters across the country, starting with Hurricane Katrina in 2005 and right up to the Texas cold snap of 2021, serves as a warning that we are not as effective at adapting at even today's level of risk as we should be. Before delving into the causes of the U.S. adaptation gap, let me point out some encouraging experience. In the U.S. and worldwide, even as property damage has increased along the coast, deaths in coastal storm surge since 1900, for instance, that accompanying hurricanes, have decreased. While the reasons for this trend remain unclear, improved forecasting has in all likelihood made an important contribution. Now to the bad news. Recent events show that we are still leaving much too much undone before a big event strikes. For example, in 2012, Hurricane Sandy struck a metropolitan area, New York, where I live, that seemed to have grown complacent due to the lack of catastrophic coastal events in the preceding decades. For example, the subway system, the lifeblood of the city, was flooded and shut down for 3 to 4 days and parts almost ruined. Yet 9 storms in the 60 years previous to that had almost flooded the subway system, and little or nothing had been done to protect it. And that's not just a city responsibility, it's the state also. Our current ways of dealing with climate-related risk create incentives for people and government officials to do precisely the wrong thing. A prime example is the imbalance between federal funding available to assist states and local governments to plan and implement adaptation measures to avoid disaster compared to the amount of money spent for cleanup after an extreme event. Even more distressing is the insufficient attention at all levels of government to the most vulnerable groups. Extreme heat, the leading cause of climate-related death in the U.S., provides a vivid example. Evidence from the period 1987 to 2005 suggests a decrease in heat-related deaths for the overall population, but a constant death rate for people 65 years and older. Cities deal with this risk by establishing cooling centers. However, one recent study of Phoenix, New York, and Chicago showed that the locations of these centers bear no systematic relationship to the vulnerable populations that need the most, and distances from their neighborhoods to the cooling centers were often such as to make the centers effectively inaccessible to those aged, ill, or without motor vehicles. The current U.S. system for dealing with climate adaptation is highly fragmented across many dimensions and must be reformed across the board to keep us from falling far behind as the climate warms, especially for those who are vulnerable due to age, illness, persistent discrimination, or economic status. I'd like to thank the committee once again for affording me this opportunity to testify.
Was mooted. Let me thank you very much, Dr. Oppenheimer, and call for Dr. Housefather to do his testimony.
Thank you. Good morning, Chairwoman Johnson, Ranking Member Lucas, and members of the committee. My name is Zeke Housefather. I'm a climate scientist and Director of Climate and Energy at the Breakthrough Institute. In many ways, 2020 was the year in which both climate change and the accelerating energy transition became impossible to ignore. On the climate front, we saw 2020 tie with 2016 as the warmest year since records began, with global temperatures of around 1.3 degrees centigrade, or 2.3 degrees Fahrenheit, above temperatures of the late 1800s. Land areas, where we all live, were nearly 2 degrees centigrade, or 3.6 degrees Fahrenheit warmer. We saw devastating wildfires in California and Australia, extreme heat in Siberia, and the second lowest level of Arctic sea ice ever observed, among other climate extremes. At the same time, the world has made substantial progress in moving away from the worst case outcomes of climate change over the past decade. Rather than a 21st century dominated by coal that energy modelers foresaw, global coal use peaked in 2013 and is now in structural decline. We have succeeded in making clean energy cheap, with solar power and battery storage costs falling tenfold since 2009. And the world has produced more electricity from clean energy, solar, wind, hydro, and nuclear, than from coal over the past 2 years. And according to major oil companies, peak oil is soon upon us, not because we have run out of cheap oil to produce, but because demand is falling as consumers shift to electric vehicles. Current policies adopted by countries today put us on track for around 3 degrees centigrade of warming by the end of the century, compared to the late 1800s. Including pledges and targets, such as those in the Paris Agreement, brings us down to 2.5 degrees centigrade. We have seen a proliferation of longer-term decarbonization commitments in recent years, with countries representing around half of global emissions, including China, pledging to reach net zero by 2050 or 2060. If these longer-term commitments are achieved, it would bring end-of-century warming down close to the global target of 2 degrees centigrade. Now, some caution is warranted here. Long-term pledges should be discounted until reflected in short-term policy commitments, and warming could well be notably higher or lower than these best estimates, given scientific uncertainties surrounding both the sensitivity of climate to our greenhouse gas emissions and likely changes in the ability of the land and oceans to absorb a portion of what we emit. CO2 accumulates in the atmosphere over time, and until emissions reach net zero, the world will continue to warm. This is the brutal math of climate change, and it means that full decarbonization of our economy is not a matter of if, but when. Cost declines in clean energy go a long way toward making deep decarbonization more achievable at a lower cost than appeared a decade ago. Low-cost renewables can provide a sizable share of our energy needs in modern grid integration models. In the near term, however, America's cheap and abundant supplies of natural gas will play a key role in filling in the gaps as we build up more wind and solar and keep existing clean energy sources like nuclear online. In the longer term, there's a growing recognition of both the need for complementary technologies, such as grid-scale storage and long-distance transmission, as well as clean, firm generation, like advanced nuclear, enhanced geothermal, and gas with carbon capture and storage, to ultimately wean the system off its dependence on natural gas. Studies have consistently shown that low-carbon power grids with a sizable portion of clean, firm generation are a lower-cost option than wind, solar, and hydro alone. CO2 removal technologies will also play an important role to offset the long tail of hard-to-reduce emissions from sectors like aviation. The 2020s is the decade to invest in maturing a range of technologies that improve options for the long term. Debates around climate mitigation are often framed as a choice between the technologies we have today and future innovations. In reality, we need to do both, to deploy what is cost-effective today and to invest in the range of solutions needed to tackle the hard-to-decarbonize parts of the economy. The recent omnibus bill takes an important step in this direction, authorizing billions of dollars for investments in clean energy, vital energy R&D, and grid modernization. It shows that there is real potential for bipartisan energy solutions that both reduce emissions and create jobs. If we want to ensure that the rest of the world follows the US lead in reducing CO2 emissions, there is no better step we can take than making clean energy technologies cheaper than fossil fuel alternatives. Making clean energy cheap can set the US up to be a leader in developing and selling these technologies to the rest of the world, while building new industries and creating jobs at home. Climate change impacts pose a serious threat to our way of life, but are unlikely to lead to human extinction. However, existential risks are an unnecessarily high bar to take action. Nearly every other challenge we have dealt with in the past, poverty, war, hunger, disease, do not literally threaten the survival of our species. The impetus to mitigate climate change is less about enabling humanity to survive and more about enabling it to thrive, and to leave our children a natural world that, while far from untouched, is at least largely intact. Thank you.
Thank you very much. We'll now hear from Dr. Diffenbaugh.
Thank you, Chairwoman Johnson and Ranking Member Lucas for the invitation. My name is Noah Diffenbaugh. I'm a professor and senior fellow at Stanford University, but I'm appearing in my personal capacity. I'll focus on the topics noted in your invitation. The brief summary is that global warming is causing extreme events to increase, including unprecedented events. We are not adapted to these changes, meaning that global warming is already impacting people and ecosystems. The greater the global warming in the future, the more these risks will intensify. Achieving the Paris Agreement goals will reduce intensification of these risks. However, even if those goals are achieved, there will still be more climate change than has already occurred, meaning that adaptation will be necessary to avoid further impacts. And finally, research is needed to develop and deploy the scale of mitigation and adaptation solutions that are necessary to curb the intensification of these risks. Disasters are ultimately the function of the difference between the magnitude of the hazard and the level of preparation. The rising risk of extremes, including heat, rainfall, flooding, drought, wildfire conditions, is causing the climate envelope, around which so many of our systems have been designed, built, and operated, to be exceeded with increasing regularity, from our disaster management systems to our electrical grids to our water and transportation infrastructure. This past year, while the Western US was in the midst of its most severe wildfire season in recorded history, the Atlantic had a record-breaking hurricane season. In both cases, there are multiple lines of evidence linking historical global warming to elevated risk of extreme conditions, including increased probability of extreme wildfire weather and of extreme precipitation and storm surge flooding from landfalling storms. And these are just two of the most recent examples. In the absence of adaptation, we can expect more big disasters to happen in more places, more often, with poor and marginalized communities experiencing the greatest vulnerability. And this is already costing us. My research group recently documented that historical changes in precipitation account for approximately 1/3 of the cumulative flood damages in the US in the past 3 decades. Similar methods suggest that historical warming has cost the US economy approximately $5 trillion in aggregate growth within the past 2 decades. These economic impacts are likely to accelerate at higher levels of warming, with the poorest counties being harmed around twice as much as the richest counties. Fortunately, there are options. Extreme climate conditions will intensify less at 1.5 or 2 degrees C than at 3 or 4 degrees C. These lower levels of warming are also very likely to reduce the level of impact on the economy, on our food and water systems, and on human and ecosystem health. There is thus substantial benefit to achieving the Paris Agreement goals. In addition, many of the mechanisms that we have for reducing emissions can also increase resilience to climate stresses by providing critical energy resources to communities whose well-being has been hampered by energy poverty or pollution, and by increasing the resilience of the energy system overall. We can also increase resilience by investing in marginalized communities, which we know are both more vulnerable and more exposed to climate stresses. And carefully considering how and where we build and how we preserve and manage ecosystems as we meet the growing needs for fair and equitable housing and livelihoods is important for managing a range of climate risks, including wildfires in the West, hurricanes in the Southeast, and floods in the Midwest. In your invitation letter, you asked me to identify recommendations for additional investments in climate science. Given what I've described, successfully managing the risks of climate change will require acceleration of both mitigation and adaptation. We have sufficient understanding to begin that acceleration. And given the scale of solutions that are necessary, additional research is also needed. A cohesive research agenda that integrates mitigation and adaptation in support of a climate-resilient nation would include the following themes: improved observational and modeling capacity for predicting extreme events across scales, R&D for the technologies and deployment necessary to transition to a secure, reliable, equitable, net zero emissions energy system, improved understanding of the climate impacts of overshooting the Paris Agreement goals, R&D for development, implementation, and deployment of adaptation approaches across a variety of geographic, climatic, and socioeconomic contexts, new methodologies and decision support for updating our infrastructure and disaster risk management to accommodate the growing likelihood that multiple unprecedented events occur simultaneously, and improved understanding of how to generate synergies between mitigation, adaptation, and other policy priorities, like economic growth, job creation, environmental conservation, and economic, racial, and environmental justice. I applaud the committee for working on these critical issues, and I look forward to your questions.
Thank you very much. We'll now hear from Dr. Bontempi.
Chairwoman Johnson, Ranking Member Lucas, members of the committee, thank you for the opportunity to discuss the state of the science regarding Earth's climate crisis. Today, I will highlight the role of the oceans in Earth's climate. I deliver this testimony from Narragansett, Rhode Island, the traditional land of the Narragansett tribal nation. I deliver this testimony to the U.S. government centered in Washington, D.C., the homeland of the Nacotchtank, or Anacostan people. I honor their histories and ancestors and perseverance in our communities today, as our communities were built on Indigenous land. We acknowledge the Indigenous people and honor their stewardship of the land, sea, and resources that they hold sacred. The fourth National Climate Assessment, Volume 2, highlights the disproportionate impact of climate change on Indigenous communities. This threat is highlighted in IPCC's special report on oceans and cryosphere in 2019, and is especially relevant to our discussion today, as social and environmental justice must be central to our climate strategies and solutions. For the last 7 years, Earth's global average temperature has been the warmest on record. This warming is dramatically changing the physical characteristics of the ocean and altering its ecosystems in unprecedented ways. These impacts are felt today and will continue for decades, and their duration will extend even longer if action is not taken to rapidly reduce greenhouse gas emissions. I will point out that a lot of the long-term trends that we see in climate would not be possible without Earth-observing satellites today. The ocean exchanges large quantities of heat, water, and carbon dioxide with the atmosphere, absorbing approximately 1/3 of annual carbon dioxide emissions. The ocean also moves excess heat, like a conveyor belt, from the tropics to the poles. Near the poles, cold, salty, and dense water sinks from the surface and carries carbon dioxide and heat into the interior ocean, where it may be stored for hundreds to thousands of years. Understanding ocean dynamics is therefore central to understanding Earth's climate crisis. The ocean conveyor belt is directly impacted by climate change, and if any or all of its major currents diminish in the future, both heat and carbon dioxide could accumulate in the atmosphere at an accelerated rate. The 2019 IPCC report presented the extreme damage being done to the world's glaciers, permafrost, and oceans by climate change. Dramatic changes are projected to continue under every emission scenario, but outcomes under a business-as-usual approach are particularly grim. However, if global emissions are capped in the near term and reduced sharply by mid-century, and if aggressive approaches are taken to support resilience in marine ecosystems and coastal communities, we may yet avoid the worst impacts. Ocean chemistry is impacted by carbon dioxide uptake from the atmosphere, and since the beginning of the Industrial Revolution, this uptake has increased the acidity of the surface ocean waters by 30%. In tropical oceans, warming and acidification have increased coral bleaching, mortality events, and reef decline worldwide over the last 2 decades. The 2019 IPCC report identifies additional changes in ecosystem distributions and migration patterns. On average, marine species have moved poleward at rates of up to 50 kilometers per decade since the 1950s, and sometimes more. Climate change impacts on ocean physical and chemical properties cause additional wide-ranging ecosystem responses, including frequent harmful algal blooms, altered ocean plant growth, reduction of fish stocks, many of which are either fully exploited or overexploited already. The diverse climate change effects threaten foundations of marine food webs, putting whole ecosystems and those who rely on them for food and jobs at risk. Substantial and sustained reductions in global greenhouse gas emissions will significantly reduce projected risks to ocean ecosystems and communities that rely on them. We need investments in research and management. Here I would like to recognize and applaud Congressman Grijalva and Congresswoman Bontempi for their introduction earlier this year of the Ocean-Based Climate Solutions Act, which includes many needed steps for adapting to and mitigating climate change impacts. Recent federal investments connecting research to management are groundbreaking, including the U.S. and National Science Foundation's contribution to an international global profiling robotic network measuring key ocean properties essential for understanding ocean carbon cycle and ecosystem health. Coupling these observations with new Earth-viewing satellite data, such as NASA's Plankton Aerosol Cloud and Ocean Ecosystem Mission, and potentially groundbreaking technologies like ocean profiling LiDARs, will provide researchers and managers unprecedented local and global scale observations of our living marine resources. I applaud these investments, but they're an appetizer. Modeling is also particularly important for climate change research and impact adaptation and mitigation studies. We must facilitate and capitalize on investments in science, technology, engineering, computing, architecture, and education. These investments are strategic, tactical, and sustain our blue economy. And all of my points point to one pivotal need: To understand climate change and its impacts on the Earth, we need sustained investments in global observing networks and high-performance computing, integrated with science communication, public engagement, and education programs. We need a well-trained, interdisciplinary, climate-literate workforce, including natural and social science, as well as policy experts, engineers, and educators. As we look ahead, we must allow our science questions to evolve as our needs change. We must begin to meaningfully invest in adaptive science and support adaptive and sustainable management of marine resources. And we must never forget that climate change as a crisis is no longer a threat of the future, but a reality occurring already today. Thank you for the opportunity to discuss these topics. I look forward to questions.
Thank you very much. That completes our outstanding witnesses, and at this point, we will begin our first round of questions. I will recognize myself for 5 minutes, and then Mr. Lucas, and after that, the clerk will call on the persons for their questions from the queue. Extreme heat is the deadliest climate-related event in the U.S., and cities are the most vulnerable. Although I must say that within the last month, in my hometown of Dallas, who is known for its heat, would argue at this point whether or not it is heat that bring forth most of the temperatures that are out of line with what we consider normal. Dr. Oppenheimer, you discussed in your testimony how climate change will cause more frequent, more intense, and longer heat waves. You also note how populations are more vulnerable to heat than others based on race, income, health status, or age. How are these vulnerable communities being disproportionately impacted by extreme heat? And what are the consequences of failing to design policies that recognize and address these impacts?
Thank you, Congresswoman. People, as I pointed out, die in higher numbers in extreme heat than any other climate-related event in the United States. And, you know, if you look at the way extreme heat is handled in much of the country, because it kind of is something that people think they're used to, there isn't really a very effective system for adapting to it. But what happens instead is that it goes on the back burner and people are expected to have air conditioning. Well, a lot of people can't afford air conditioning. In central cities, you get situations where people are too poor to have air conditioning. They live in apartments which don't have very good ventilation, in many cases afraid to open the windows for security reasons. So again, it's the disadvantage that extreme heat hits with particularly hardest. That, in addition, the statistics don't capture very well people who die due to the indirect effects of extreme heat. For instance, the interaction of heat with air pollution. Again, people who tend to live in underserved areas, central cities, areas where people who are poor or have suffered various forms of discrimination are disproportionately represented. But that's a problem. It's a problem for the society as a whole. It's a problem for those particular populations.
Thank you very much. Now, we consider climate literate workforce, and I'd like to have some comment on what do we mean by that. Dr. Bontempi, in your testimony, you described that one critical and often overlooked component of science-based policy solutions is a need for a climate literate workforce that is trained in the natural and social sciences as well as policy. The U.S. produces some of the best climate science in the world to inform climate adaptation and mitigation strategies, but we need a climate literate workforce to turn these goals into reality. How do we provide that right interdisciplinary and multidisciplinary training to build that workforce that is prepared to tackle these complex challenges?
Thank you, Congresswoman, for the question. It's a good one. So what we have to do on the whole is start blending interdisciplinary and multidisciplinary science and research into our teaching curricula. We have to acknowledge the needs and desires of our growing workforce. We have to provide mentorship, and we have to provide pathways and investment into research that facilitates the training of students, and we have to start early. We have a global population of young people that are unbelievably connected to each other, to their environment, and to their role in the Earth system and the climate as a whole. We actually also need to focus on historically marginalized or excluded groups, and we have to create a safe environment for them to join the workforce. We have to provide a support network, we have to provide mentorship, and it's not enough to just recruit people. We have to focus on retention, advancement, and placement, and we have to shepherd all students through these pieces. So people are very focused on this. They're very interested in this. When I look at the campus that I'm a dean on, the Narragansett Bay campus at the University of Rhode Island, I have seen a real shift in working desires of the students to not go just the tenure track faculty positions, but into positions where they can actually have an immediate impact on the world. Blended into this is also our capability to communicate our science. Science communication and inclusive science communication cannot be an afterthought in the research that we pursue or the education that we pursue. It has to be blended in from the start. And I think if we start to follow these pathways, we'll have a lot more success, not only in creating a climate literate workforce that thinks of the Earth system and not just their backyard, and also has the reach globally.
Thank you very much. Mr. Clerk, what is my time like?
I believe it's expired, Ms. Johnson.
Thank you very much. I now recognize Mr. Lucas.
Thank you, Madam Chair. I'd like to turn to Dr. Housefather. In a recent report published by the Breakthrough Institute, which you co-authored, you refer to climate policy as quiet if it swims with the tide of existing socio-political institutions and economic growth, if it uses technology and infrastructure as its main lever, and if it disrupts rather than exploits political partisanships. That's the kind of policy I've always aimed to achieve because it's what I refer to as the carrot, not the stick approach. To you, what comes to mind as examples both of non-quiet policy proposals and some examples of quiet policy proposals? Doctor?
Thank you for your question, Congressman. So I think it's important to emphasize that what we call quiet climate policy is not necessarily an alternative or statement of opposition to setting broader goals, such as nationally determined contributions in the Paris Agreement. Rather, it's a recognition that to meet those goals, we need real bipartisan climate solutions. So quiet climate policy seeks to make substantial forward progress, recognizing the realities of divided government. Seeks to create durable policy that will not change with every new administration. And I think the recent energy bill was a great example of quiet climate policy in action. When we think of quiet climate policy, there's really three pillars. First, it involves a recognition of the importance of government investment in research, development, and deployment. Most of the technologies that are reducing emissions today were enabled by decades of sustained RD&D efforts made by federal and state governments. We need additional advances in both clean firm generation in the power sector and advances for hard to decarbonize parts of the economy like long distance freight, aviation, industrial heat, and agriculture. A focus on RD&D also includes demonstration and early stage deployment. The FORGE program for geothermal is a great example here, as is the Nuclear Energy Leadership Act to enable the deployment of first of a kind advanced reactor designs. Second, investments in infrastructure are needed to support the energy transition. While we can endlessly debate about the right amount of renewables on the grid, what is clear is that given their impressive and continuing cost declines, we will have more in the future than we have today. That will involve modernizing our electricity grid, including investing in high voltage, long distance transmission and interconnections, as well as grid scale storage. And finally, while there's a need for broader mitigation policies, we should try to do so in a technologically neutral way. While picking winners is fine for early stage technologies, it is more problematic for mature technologies whose deployment is primarily being driven by market forces. We should also recognize that technology enables policy. It is a lot easier to nudge a system further in a direction that is already heading than to try to turn it around. And the advent of cheap energy, or cheap clean energy, has dramatically reduced the expected cost of mitigation. We should be a bit humbled by the rate of change enabled by making clean energy cheap. We have exceeded both Waxman-Markey goal of 17% reductions in emissions by 2020, even including COVID impacts, and the Clean Power Plan goal of a 32% reduction in the power sector emissions by 2030, despite neither being enacted. This is not to say that there's not a need for policy, but rather to highlight the importance of both technology and policy in solving the problem.
No, Doctor, it's been my experience a lot of times, whether when I was in the state legislature and Congress, sometimes we get in kind of an echo chamber effect, and that happens both at the state capitals and the U.S. Capitol. Would you agree that the public wants to see responsible action on energy climate change?
I think there is a desire for action on climate change, and in a way that supports the building of American prosperity in the long term. I think that we have shown in the past decade that taking strong action on climate change need not require large-scale sacrifices by the American people, and that through smart policy, we can both build our economy and reduce our emissions at the same time.
Dr. Newhouse, you used shale gas unlocked by the fracking revolution as an example of sustained technology-specific research, development, demonstration, deployment efforts by the federal government. And it took less than a decade for research at DOE's national labs to lead to the U.S. becoming the world's leading natural gas producer. For something advanced nuclear reactors, geothermal energy, direct air capture research areas, which are well underway at the national labs today, should we have expectations similar to shale gas potential results? And for that matter, does the Energy Act of 2020 speed the timeline up significantly for these things?
So we can't know what future investments will sort of catch lightning in a bottle in the way that horizontal drilling and hydraulic fracturing did. And we shouldn't put all of our hopes in any single future technology, be it carbon capture and storage, advanced nuclear, hydrogen, direct air capture, or any others. Rather, we should try to be pretty ecumenical in our investments into a wide range of future decarbonization technologies, recognizing that the market will ultimately drive the deployment of what proves to be cost effective. In the case of sort of the fracking revolution, it's important to emphasize that it wasn't just federal R&D. There were tax credits, demonstration projects funded by a FERC-approved surcharge on natural gas pipelines, and other measures that really drove it forward. And investments that led to the fracking revolution took place over decades at every stage of the RD&D pipeline. So I think it is a good example of the type of federal investments in basic R&D that can have dramatic effects on the energy system, as are prior investments in solar photovoltaics and battery storage. And I think more of these are needed for the harder to decarbonize sectors of the economy and for sort of clean, firm generation sources that will provide an important part of our future electricity mix.
Thank you, Doctor. And I yield back, Madam Chair.
Thank you very much, Mr. Lucas. I'll now call on the clerk if he will start to ask our members to use their 5 minutes of questioning.
Thank you, Madam Chair. Ms. Bontempi is next.
Thank you so much. Thank you, Chairwoman Johnson and Ranking Member Lucas, and really thank you to all of our witnesses for this productive conversation. In Northwest Oregon, the climate crisis isn't a distant threat, it's our reality. And the testimony from our witnesses today demonstrates this. I think in many ways, we here have seen raging wildfires creating hazardous air quality, increased flooding, sea level rise that jeopardizes our coastal communities, and ocean acidification. We know that the climate crisis is a national emergency, and we know we need to implement bold policies to solve it. Last year, I joined my colleagues on the Select Committee on the Climate Crisis, and we released a comprehensive science-based roadmap to reach net zero emissions no later than mid-century, net negative thereafter. And I look forward to working with my colleagues on this committee to advance the recommendations and legislation in the Climate Action Plan. We know that carbon dioxide from human-caused greenhouse gas emissions is causing our ocean and estuaries to become more acidic. Ocean acidification makes it more difficult for marine organisms to build their shells. But now we also know that it's causing some finfish, including endangered salmon, which are a fundamental part of the identity and culture of our Northwest tribes. It's causing them to lose the sense of smell that they need to survive and reproduce. Last week, I introduced my Bipartisan Coast Research Act, which is a comprehensive bill to expand scientific research and monitoring of ocean and coastal acidification and help coastal communities adapt. So I'm going to direct my questions to Dr. Bontempi. First, thank you, Dr. Bontempi, for your acknowledgement of the Ocean-Based Climate Solutions Act. I want to start by asking, how can we apply our current understanding of ocean acidification to implement even stronger adaptation and resilience strategies?
Yes, we definitely need to apply the information we have to strategies for the future. And as I said, I acknowledge the way you phrased it, blending research and management approaches and solutions. Right now, I'd say the hardest thing, one of the greatest challenges for scientists is actually collecting enough information so they understand different aspects of what's happening. I'd go so far as to say off the Oregon coast and even in the state of Oregon, the last decade, you have a new seasons to look at, right? Hypoxia seasons, ocean acidification seasons. The reason that scientists are able to understand what's happening is because we have long-term time series. So I would recommend, continued investment in observations of our ocean at the surface, down deep, on multiple scales at the local, regional, and global scale, to understand what's happening in the ocean physically, chemically, biologically, so you can understand how to manage your local marine resources. I think the other piece is thinking about things like the modeling capability. Do we have all the pieces in place to actually model our marine ecosystems? This is a cutting edge area, right? We're very good at putting things in sort of a black box, but we don't know all the processes that happen in the ocean related to ocean acidification and the impacts on marine ecosystems. And as you point out,
but I really want to get another question.
Oh, I'm sorry. Go ahead.
I wish we had more than 5 minutes. So I was glad that you mentioned the high level panel for sustainable ocean economy in your testimony. So in 2019, in the report, the panel found that the protection and restoration of coastal blue carbon ecosystems could prevent approximately 1 gigaton of carbon dioxide from entering the atmosphere by 2050. So I'm going to soon reintroduce my Blue Carbon for Our Planet Act to map, protect, and restore blue carbon ecosystems. So as the United States, as we establish our next nationally determined contribution under the Paris Climate Agreement, can you please expand on how and why a better assessment of the sequestration potential of blue carbon ecosystems would be useful?
Sure. Blue carbon will be an important part of our planning strategy for carbon, cycling in the future. I think anything in the coastal zone where land meets water, wetlands, seagrasses, things like that, have the ability to capture carbon and actually utilize it and recycle it. And that will be very important. One of the things that's very alarming is that with all of the sea level change, sea level rise, coastal inundation, and things that come with it, these areas are being highly impacted by climate variability and change. And so we're going to have to also take steps to conserve these areas to support them and enable marine and coastal resilience.
Right, and that restoration work is great for the coastal communities as well. So my time is just about to expire. Again, thank you to all our witnesses, and I yield back the balance of my time.
Mr. Posey is next.
Thank you, Chairwoman Johnson and Ranking Member Lucas, for holding this hearing. It is important to discuss the importance of climate change research and the push toward lower carbon energy. We all support moving to lower carbon energy, and we've made a lot of progress already, but it would be wrong to ignore the impact on the people we're elected to serve. I'm particularly interested in hearing from the panel what they would say to senior citizens in Florida living on Social Security about double or tripling their electric bills because of the higher costs associated with lower carbon energy. The administration announced a plan to eliminate carbon emissions from the electric sector by 2035 by pushing wind, solar, nuclear, and other lower carbon energy resources. This previous date was 2050. Florida uses mostly natural gas for electric generation. And according to the Florida Municipal Power Agency, the cost to convert natural gas to renewable energies by 2035 could increase Florida's electric bills by 200 to 300% on an annual basis. The current monthly residential electric bill in Florida is $123. That's about 8% of the average Social Security recipient's monthly income. Doubling or tripling of their electric bill would end up taking 18 to 25% of their annual income. I'm concerned about moving the goalposts from 2050 to 2035. how do any of you think we could best explain the increase to senior citizens who we all represent when, according to the Social Security Administration, they earned an average of just $1,452 per month as of December of 2019. Anyone can answer that.
Let me take a shot at that. Let me answer it a little more generically. I think there are a lot of people who will gain and some people that will lose if we do a rapid energy transmission. That's in the nature of change. But what shouldn't happen is that these groups, and that includes, for instance, the coal mining communities, be allowed to fall through the bottom of whatever safety net we have in this country. And so I, would fully endorse an approach that, in fact, I'll say I doubt a solution to this problem is possible unless we afford the appropriate protection to people who might be hurt. And we've done so in the past. Electric bills to low-income families received support, at least during the energy crisis 40 years ago. It's been done before.
To echo Dr. Oppenheimer, I think that we can certainly move forward in an energy transition in a way that does not increase people's bills. Now, whether or not we get all the way down to zero in the electricity sector by 2035, or say 80 to 90% of the way there, I think is still a bit of an open question. Renewable energy is very cheap at the margins today, but once you get closer to 100% decarbonization of the system driven by renewables, you start getting much higher costs associated with the complementary technologies like battery storage and whatnot. And so, a world where we get 80, 85, even 90% of the way there by 2035, while still having a fair amount of natural gas backup to fill in the gaps between intermittent generation, is a much lower cost system than one where we get all the way to 100%. Now, by 2050, the longer term decarbonization target, we will hopefully have more mature alternative technologies to fill in those gaps in a cost-effective way. And so I think we can definitely, both decarbonize while hopefully reducing, or if not reducing, at least keeping costs similar to they are today for most customers. And I think it's just important that we make sure we do that in the right way. And there's been a number of recent US decarbonization models that I referred to in my written testimony that are very instructive there, including by folks like Dr. Chris Clack and Dr. Jesse Jenkins, who's testifying before you guys next week.
Yeah, I would add, just following up on that, I think Ranking Member Lucas makes a good point about investing in more technology development. How can we use those new technologies to produce a cleaner energy economy that doesn't create more expensive for those that can't afford it?
Yeah, I would add in this discussion, including the statement you just made, it's critical that the distributional impacts of policies are quantified and considered. And that's both for policy actions that your committee is considering, as well as for the impacts of the climate changes that are happening. And that cost benefit analysis is, requires both sides of the equation. And I'll just amplify that. We have clear evidence that global warming is already costing Americans billions of dollars a year. We know from the contribution to climate and weather disasters that's already cumulatively billions of dollars a year, and then in the impacts on economic growth, those economic impacts are even greater. And I'll go back to the chairwoman's question about.
Sorry, my time has expired, and I have to yield back. Thank you, Madam Chairman.
Ms. Sherrill is next.
Thank you, and thank you to our chair and ranking member for calling such an important discussion, and our panelists as well. Dr. Oppenheimer, in 2012, Hurricane Sandy ravaged New Jersey. It was the most devastating, costly storm in New Jersey history, and it turned the lives of thousands of families upside down. With a greater understanding of climate events, our state may have been better prepared to handle the adverse impacts of the storm. We also see people in Texas making decisions about resiliency that would be better made with an understanding of the adverse impacts of climate change. So how have recent updates to climate science improved our understanding of the timing, intensity, and location of climate events?
Well, as far as location is concerned, one of the big challenges is always predicting something at a scale that's really meaningful to people in enough detail. And the big changes in the climate computer models that do the forecasting is the increase in resolution of those models. So it's become gradually more and more possible to make statements about climate change that are true of not just a continent or a hemisphere or even a region like the Northeast, but that are more specific. So the support that's gone into climate modeling has been absolutely crucial in helping communities like the ones on the Jersey coast that were so devastated look to the future, plan and implement those plans for protection in the future. It's also true that we're never going to get perfect at it. And that to some extent over the next decade or two, we're going to have to rely with some impacts on generalities that are just beyond the capabilities of the models.
Thank you. And then I'd love to turn to Dr. Diffenbaugh about harmful algal blooms. They now occur more severely and more often and in more bodies of water due to the impacts of climate change. And they're a serious environmental and economic threat to New Jersey and states across the country. Lake Hopatcong in my district is the largest freshwater lake in New Jersey, and it was closed for most of the summer in 2019 due to have outbreaks impacting residents, businesses, and the economy of Northwest Jersey. So what has led to the improvements in our ability to quantify impacts and societal risk associated with climate change? And how can we ensure that these efforts continue?
Well, the risks from climate change result from the intersection of the physical hazards, whether they're storm surge, heat, drought, etc., as well as the intersection of those physical hazards with exposure and vulnerability. And certainly, there are a number of scientific studies on harmful algal blooms, for example, showing that intersection in the Great Lakes, for example, and other regions. So certainly the human dimension is critical. And as we heard earlier, in terms of research for understanding these intersections of the physical climate hazards with the exposure and vulnerability of people and ecosystems, we clearly need improved research at the nexus of physical sciences, social and behavioral sciences, in order to understand, what solutions would be necessary to prepare for, and in the case of the algal blooms that you're mentioning, reduce or prevent those events.
As you can imagine, we look at huge costs associated with different climate events and the impact they have in the aftermath. And so as we're forward-looking and trying to make decisions on where to most efficiently spend money for infrastructure resilience, for example, I'm wondering what more Congress can do to help our communities make these costly decisions and make them better. For example, if it's going to be a once in 100-year storm, maybe you make different decisions than if it's going to be a once every 5-year storm type situation. So I'm just going to open it up in my last few seconds to the panel. If you have any ideas on how Congress could better support decision making like that.
Well,
yeah, we need.
Go ahead, Noah. Go ahead.
Well, I think we now have clear evidence that the methods that have been used historically of using the historical envelope of climate extremes are not applicable to the present climate that we're in. And so I think research into how to improve the combination of climate forecasts and climate observations and statistical analysis to improve those hazard calculations will be critical for the design and operation of infrastructure going forward.
Thanks so much. I'm afraid my time's expired. Thank you so much.
Mr. Weber is next.
Mr. Weber, you are muted.
Mr. Weber's having technical issues. Why don't we go to Mr. Babin next?
Thank you. Thank you, Madam Chairwoman and Ranking Member Lucas. Thank you to our witnesses for being here today. And Houston is home to a cutting-edge, state-of-the-art technology that is revolutionizing how we produce our energy. I'm proud to represent Houston and many of these companies, and will continue to advocate for a stronger and more secure energy industry here in the United States. When we have a debate over carbon emissions and greenhouse gases,
can y'all hear me?
Can y'all hear me? I think am I in the middle of this?
Can you hear me now?
Madam Chair, can you hear me?
Yes, we can hear you, Mr. Babin.
Yes.
Mr. Weber, we moved along to Mr. Babin due to your technical issues, and then we will circle back to you as the next Republican. Please continue, Mr. Babin.
Pardon me? Pardon me?
You're recognized to continue, Mr. Babin.
Okay. Yeah, somebody's, especially when regulations become so burdensome here that our companies are forced to outsource production to these countries with very few regulations. We have to remember that these are countries willing to do anything to get ahead of the United States. So, Dr. Housefather, I'd like to ask you, China's commitment to reach net zero emissions by 2060 was heralded as a potential game changer, but it lacks the details to make me really believe that it will happen. It doesn't show how China plans to decarbonize by 2060 or peak their emissions by 2030, which leaves many critics rightly being skeptical. Additionally, it also doesn't disclose a specific question is, how do we hold these other countries accountable, especially those like China, when they don't play by the same rules that we do? Dr. Housefather.
Thank you, Congressman Babin. So I think it is very important that we ensure that we hold countries to the commitments they've made. And in the case of China, you know, it's still early and there's some very mixed signals coming out of the new 5-year plan in terms of how, you know, seriously they're going to reflect these long-term commitments in short-term policy. Now, I suspect China's emissions will probably peak sooner rather than later, but the magnitude of the decline that they've promised is a very different story. And so, you know, I think there's a few things that are important to consider here. One is, you know, the potential to consider things like carbon border adjustments in a carbon constrained future where we actually can punish countries and products coming from countries that are laggards in this space. Another area of focus should be on, you know, making it so we in America are innovating and creating cheap technologies that countries like China and India, for that matter, can purchase themselves. Because again, if they have options that are cheaper than burning coal for electricity generation and do not produce the, you know, staggering levels of pollution that are huge problems in those countries, they will transition to those. And so, as I mentioned in my testimony, I think the real key to getting middle-income countries like China and India that will be the biggest drivers of emissions this century to follow the lead of the US in reducing our emissions is to make clean energy cheap, is to give them compelling alternatives to using coal, to using oil, in a way that does not get in the way of their economic growth. And I think that is an achievable goal, and it's something we've seen an immense amount of progress on.
All right, thank you very much. Expounding upon that same point, China's overall CO2 emissions in 2020 increased by 0.8% from 2019 levels. And that was in the middle of a pandemic. This originated in a pandemic which originated in China, where many other nations saw that.
I think we lost him.
Yes, ma'am. Mr. Babin's connection appears to have frozen. We're also investigating possible network issues on House campus.
I'll just add on this topic that, as Dr. Housefather said, the U.S. can be a source of innovation for enabling leapfrogging to lower carbon energy sources. I'll also note that the global warming is proportional to the total cumulative emissions. The U.S. is around a quarter of the historical cumulative emissions, and as has been published in The Economist and elsewhere, China, India, Indonesia are actually decarbonizing faster in terms of their per capita GDP than the US and Western Europe have. So those countries are actually on a more rapid decarbonization pathway relative to their economic growth.
Yeah, and I'd chip in also that the comment that Zeke made about border tax adjustments, while they're a heavy instrument, may well be the only way to see that any of these things are enforced on an equal playing field, and that countries that make commitments and then take advantage of them in international trade are prevented actually from doing so, because countries have the right to protect themselves by compensating if they themselves have an honest and strong carbon reduction program.
Thank you. Mr. Bowman is next.
Thank you so much, Madam Chair and Ranking Member Lucas, for this important hearing that we're having today. Dr. Bontempi, you alluded to this before, but I want to go back to the comments you made about education and sort of reimagining and redesigning our education system to make sure our students are prepared, our children are prepared for the climate realities that we all are dealing with. Can you speak to what that might look like in the K-12 school setting, or even focus on the K-8 school setting? What might that look like as we prepare our kids for this new reality?
Thank you for asking about the education in the K-12 and K-8 systems. I will say I have never been a teacher in that realm. But I was a student, and I have a fourth grader, and what I can say really speaks to him is experiential learning, actually using tools that will bring what the earth is like to him. We have these incredible visualization capabilities. We have these students who are so conscious of the environment around them. And so when we have that sort of hands-on teaching, when we actually put the same tools we use for modeling and visualization in the hands of second, third, and fourth graders, they really learn and they really take to it. They are electronic literate, media literate, and we just have to make them climate literate. The tools are there.
Awesome. Thank you so much. Dr. Oppenheimer, can you speak to why investment in technology is not enough to reach our goals, and why we also need strong regulations?
Yeah, sure. And I want to say, it's not clear that there's any big disagreement between Dr. Housefather and myself on this, but I do want to emphasize one point, which is that supporting technology alone doesn't necessarily get the right result. It can move you in all sorts of directions. To assure that the federal support for technology, whether it's tax incentives or direct subsidies or some other approach, are pointed in the right direction, the combination of regulation with such technology incentives are a very effective way to produce the outcome, or at least an outcome in a direction that you want to go. And I'll point to DOE's long-standing program to increase the energy efficiency of appliances, which goes back to the Energy Security Act of 1980, I believe, which combines the development of regulation with a program of R&D support, and has resulted in monumental gains on appliance efficiency, which has really significantly reduced the U.S. contribution to greenhouse gases over a very long-term period.
You're muted, Mr. Bowman.
Thank you very much. Sorry about that. Dr. Diffenbaugh, your research group has estimated a cost to the economy from global warming of $5 trillion over 2 decades. Are you able to speak to the loss of life caused by these impacts historically? Are there any projections on your team that your team has made about the possible loss of life in poor and marginalized communities as warming continues to rise?
Yeah, thank you. And I should note that that estimate of the accumulated economic impact from the U.S. economy of annual eroding of annual GDP growth is from my colleague Marshall Burke at Stanford. There are a number of pathways by which extreme events impact human health, mortality, as well as economic and ecosystem, the economy and ecosystems. Just with respect to heat, we have clear evidence that heat affects GDP growth, labor productivity, agricultural yields, and insured crop losses, food security, migration, mental health, interpersonal and intergroup violence, cognitive performance, wildfire risks, air quality, and a suite of ecosystem impacts, including both on biodiversity and on biodiversity that is valued for ecotourism. So there are a number of pathways just by which rising heat exerts those impacts. We also have evidence of, in terms of your question on mortality, both via the direct impacts of heat on human health and via the mental health impacts. And this is also research from my colleague, Marshall Burke and his collaborators, that mental health, including suicide risk, is elevated by extreme heat.
Thank you. I yield back the balance of my time.
We'll try Mr. Weber now.
Can you hear me now?
We can.
Very good. Even a blind hog finds an acorn occasionally. Listen, it's great to be here. I will note that the gentlelady from New Jersey said earlier, Hurricane Sandy hitting in 2012, that she made the comment, she sees Texas, and I think I'm quoting her, making decisions without understanding climate change, end quote. I would say to my friend from New Jersey that Texas is such a large state that we have just about every kind of climate there is. And I see our great chairwoman nodding. We have deep freezes in North Texas, and I know that her and her son Kirk probably experienced that here about a month or so back. We have dust storms, we have floods, we have heat waves, we have hurricanes, like she mentioned, New Jersey getting a random hurricane, for lack of a better term. We have ice storms in Texas. We've had wildfires in Texas, even earthquakes in Texas, and we have high winds in Texas. And by the way, for the record, Texas is the #1 wind energy producing state in the country and #5 in solar panels. So I think we make decisions pretty well based on the fact that we have all kinds of weather and have had for a long time. So I don't think we should discount the fact that what happened recently was a once in a lifetime storm, winter storm in Texas. I'm 67 years old, never seen anything like it. But anyway, I want to go to Mr. Housefather and his exchange with Congressman Lucas. One of the comments he made was, while picking winners in early research is okay, but I think he said something to the effect that in latter times, the market should drive it. Is that pretty accurate, Mr. Housefather?
It is. For mature energy technologies, it makes a lot more sense to use what we call technologically neutral means if we want to create incentives for them. Things like carbon prices, clean electricity standards, clean energy subsidies that are not tied to any particular technology. And so that way we can, give some reward to these technologies for being low carbon, because that is a benefit that is not reflected in the market today. But at the same time, not, put our finger on the scale too much in favor of one technology or another.
Right, and we would agree, I think most of us would agree. And just a quick breakdown of the Texas grid, since I went there, it's 108,000 megawatts of generating capacity. 48% of it is natural gas, 13% coal, about 0.5% nuclear, about almost 29% wind, and almost 1% solar. And of course, we saw in that historic event that the wind generation severely hampered because the blades iced up. Of course, obviously at night we don't get a lot of solar. We don't get a lot of solar energy, and so nuclear would seem to be about one of the best possibilities for the cleanest energy. What say you, Mr. Housefather?
So I think nuclear is a really important technology. It's 20% of our clean generation today. It's our single biggest source of clean generation nationwide. And we should really make sure that we don't lose that, because a lot of our nuclear reactors today are at risk of shutting down, in large part because they can't compete with natural gas on the market. And some of that is the fact that the clean energy benefits of nuclear are not being reflected. But beyond that, as I mentioned in my testimony, there is a real need for a solid amount of clean, firm generation if we want to fully decarbonize our economy. And nuclear is one of the key technologies to get there. Now, the challenge we have today is that building new current generation nuclear reactors has proven really expensive. They've been over time, over budget. And, as Americans, we've just gotten bad at building big things. And so we need to figure out how to do that again, how to build these projects on time, on budget, so we don't lose out to China, who is really doubling down on sort of conventional nuclear reactors. At the same time, go ahead.
Yeah, well, thank you for that. And last I sound, we're good at building big fences around the Capitol. Did I say that out loud? But anyway, I do want to say that you also said, I would think you were hearing a clarion call for the federal government to get involved in producing energy. It sounds like, or paying for energy. For there's a lot of communities who the people suffer when it's hot, they suffer when it's cold. But I just want to make this point. In my opinion, it would be more appropriate that the local communities, yes, Texas, believe it or not, can make decisions for itself. It does take into account all kinds of weather patterns. And I would say that it's more appropriate to let cities and states decide what action, if any, they want to make in those endeavors, and for us to be involved in the research. And with that, I will yield back, Madam Chair. Thank you.
Mr. McNerney is next.
Well, I thank the chairwoman for this hearing, and I thank the witnesses. Your testimony is stark. It's somewhat alarming. Clearly, we need to take action. Dr. Oppenheimer, thank you for your testimony. I thank all the witnesses, really. You noted that achieving the Paris Climate Agreement goal of limiting to 2 degrees centigrade will not only require halting greenhouse gas emissions, but will also require removing carbon dioxide from the atmosphere. Carbon removal can take many forms, including a forest and ocean-based sequestration, better soil management, which I'm thrilled about in my district, direct air capture and storage. What is the state of the science on carbon removal, and what will it take to make these technologies viable?
Well, first of all, thank you for the question, Congressman. I'd like to say first that it's not clear how much what are called negative emissions we will need, that is carbon removal, because we don't know really what the business as usual baseline emissions are going to be. But let's assume we're going to need some if we're to get close or actually comply with the Paris well below 2 degrees Celsius target. The technology that's been talked about recently is, as you mentioned, direct air capture. It's One in which we kind of know all the pieces, but we don't know together at a price that's commercially acceptable. So the National Academy came out with a report, I think 2 years ago, asking for a substantial federal commitment to R&D on direct air capture. And I think that's a wise investment among many that should be made on ways to avoid having too much carbon in the atmosphere. Of course, it goes without saying that we ought to get our act better together on using natural ecosystems as carbon reservoirs. And that means, first and foremost, finding ways to assist the global move towards any deforestation.
Well, thank you. Well, even if we eliminate carbon and other greenhouse gas emissions, the planet's going to continue to warm for years or even decades because of the greenhouse gases already in the atmosphere. I worry that we're going to go blow past the 2 degrees Celsius increase, given both the political roadblocks to measures such as a carbon fee here in the United States, and given the technology that we have available. We clearly need to develop we clearly need to reduce carbon emissions and achieve net zero emissions. We need to implement carbon renewable technology as soon as possible. But we also need to do the science necessary to understand if taking direct steps to cool the atmosphere, such as cloud brightening and injecting sunlight reflecting particles into the stratosphere, are those viable strategies? What's the risk? Dr. Oppenheimer, given the complexity of the climate system and the risks associated with further human interference in it, how do you think the U.S. should approach the field of climate intervention?
I personally feel it should approach it with great caution, that we're not at a point where we understand either the climate impacts at the regional and local level that would result, other than it can be used to offset the global warming. But people don't live in the globe, they live in places, and how it'll affect particular places has substantial uncertainty. But I think we ought to support research. I think it's important, particularly computer-based modeling of what a geoengineered world would look like. I don't think we should be out there blasting particles into the atmosphere to see the effect now. It's way too premature for that. And I'll also say there's another component to this, which is how will countries react? This is something that could be done, in theory, by one country. Can we reach agreement on how that's to be done? Once we become kind of familiar or friendly to the technology, we unleash a lot of possibilities which could lead to global conflict between countries in the long term. We ought to be very cautious.
Sure. Dr. Diffenbaugh, would you like to answer the same question?
Yeah, well, I'll echo what Professor Oppenheimer just said about the research on potential for single actor geoengineering and potential conflict. This is an area where there is scholarly inquiry, and we certainly need more of that, and we need that to be enhanced in order to fully understand the dimensions. It's certainly asymmetric with the collective action problem of greenhouse gas emissions and global warming. The greenhouse gas emissions affect the global climate system through the aggregate effects of emissions everywhere. There's no single actor that can single-handedly stop global warming from happening. That's very asymmetric with the geoengineering that was described, where there's potential for single actor, frankly, disruption, and I mean disruption in a very technical sense in terms of climate patterns regionally.
Thank you. I'll yield back.
Mr. Sessions is next. Mr. Sessions?
Yes, Mr. Sessions is recognized.
Thank you very much. I really want to commend Chairwoman Johnson and our ranking member Lucas for this meeting. I think that the most important thing that I have heard today comes from our witnesses who have talked about necessarily throwing out the occurrences of things that have happened maybe on a once in every 100-year basis and going to things that are reoccurring, working together and finding things that on a bipartisan way we can agree with that then last through administration after administration, but that become meaningful and agreements between reasonable people who are trying to make progress. One of these may be the tax credits that come from wind usage. There may be many other things that I think that would fit, but I think that the balance of this hearing should be of finding common ground. And I think after listening to our guests this morning who gave testimony, that is the most important part of what I've learned, so that we don't start and stop and move one direction and then back, but rather make meaningful money, policy, the needs of the nation to be consistent. And it is what I have enjoyed hearing from this important viewpoint of why we have to make progress and how measurable it can be if we work together in a balanced way. With that said, I am from Texas. I recognize we're going to have hearings that will be on Texas. What happened in Texas was one of those activities that perhaps Noah or Paula may have been in reference to, that it was something that happened and it might happen again. And we ought to understand how we ought to prepare for it. But that the system that was designed is designed on a regular basis to support each other. And in this case, Mother Nature made sure all 254 counties in Texas had virtually the same outcome, meaning effect. And so it diminished our ability to effectively help each other. And it's this kind of thing that we do need to study. And Michael, I think you addressed part of this. Study of facts and data can draw you to a conclusion. Michael, when I was at the old Bell Labs in New Jersey 400 or 500 years ago, we tried to learn about how often things occurred and what that impact is. And I find your balance and the balance that you bring with Noah also to this, and Paula, really helps us focus on making a difference in a bipartisan way, meaningful to where we move with each other on a consistent basis over years and set a national strategy that is not based upon outliers, but it's based on regularly occurring things. And this is one of the things that's a takeaway from me, Michael, for living in New Jersey, a Texan living in New Jersey, but around a lot of people who tried to be artful about making a difference. I'm now down to my last 23 seconds, but the last part is I'd like to thank our chairwoman, A.D. Bernice Johnson, for bringing together not just the discussion, but also bringing along Frank Lucas in a way to where we can make a difference together. My time is now 1 second. I yield back my time and I thank our witnesses.
Mr. Tonko is recognized.
Thank you. And Madam Chair, thank you for this hearing. By working to address the climate crisis, we have the opportunity, I believe, to usher in a new era of economic growth, job creation, and prosperity for all Americans. And it's clear that there is a great deal of potential for the United States to be a leader in developing climate adaptation and mitigation strategies and solutions, particularly through innovative research and emerging technologies. So, Dr. Diffenbaugh, aside from the obvious economic benefits of being a lead developer of cutting-edge technology, what else does the United States stand to lose if we do not focus on developing these technologies?
Well, we're experiencing the impacts of the global warming that's already happened, literally day after day, month after month, year after year here in the United States. And I mentioned in my opening remarks, the recent research from my group about flooding costs in the U.S. And when we look back at, the month by month flood damages, financial costs of flooding over the last 3 decades, we find that not only the most extreme precipitation events are responsible for a large fraction of the flooding, but that precipitation has been changing in many parts of the country, and particularly the intense precipitation events have been increasing the most. And what that means is that around a third of the flooding costs from over the last 3 decades are been contributed by those changes in precipitation. Those changes in precipitation are exactly what was predicted, literally decades ago. It's exactly what we have high confidence will continue to intensify. So as with this one example I've described in detail, and so many other examples of extreme events that are already impacting us here in the United States and around the world, the more global warming we have, the greater the impacts, the more it will cost. Achieving lower levels of global warming, like what's in the Paris Agreement, will reduce the trajectory of those costs and will still leave us with further change. And so, as I said in my opening remarks, we need both mitigation and adaptation. We have enough knowledge to get started on accelerating both of those. And the transition, the gap for both of those is large. And so we need research in how to achieve both of those in concert and in concert with other policy priorities.
Yeah, well, thank you for that. And again, Dr. Diffenbaugh, what are the impacts of not developing a robust climate response program in the U.S. that includes scientific research alongside the development and deployment of technology?
Well, there certainly are financial costs, various estimates, including from my colleague Marshall Burke and I, are in the trillions in terms of damages at higher levels of warming relative to the Paris Agreement, and that's just in the U.S. So we're facing potentially trillions of dollars in eroded economic growth, and just as important, we're facing an increasing intensification of the kinds of once in a lifetime events that we're experiencing more and more frequently. It's not just that we're now more aware of everything happening everywhere all the time. It's actually true that these unprecedented events are increasing in frequency. And I would say that the biggest transition in both our thinking and our research that's needed for curbing these events, for not being caught off guard and incurring these huge costs, is an acknowledgement that we are now in a climate, and we will continue to be even in a more intense version of a climate where unprecedented events are happening, overlapping in one place, one after another, and overlapping in different parts of the country at the same time. And so what used to be "this never happened in my lifetime" is already becoming frequent, and at 2 degrees of global warming, it will become normal. And at 4 degrees of global warming, it will become, in some places, every year warmer than the historical coldest year that we know in our lifetimes.
Okay. Well, with that, I thank you, and I yield back, Madam Chair.
Mr. Garcia is recognized.
Thank you very much, and thank you to all the witnesses and Madam Chair for this very great hearing. We are in the midst of a crisis, and I applaud our collective use of the word crisis. I think when there's lives endangered and our national security is being threatened, that's an appropriate word. And I think we should apply that same concept and have the courage to apply that to what's happening on our southern border. But that's another committee hearing. I think during any crisis, the key is to make the right decisions. There's critical decision-making processes that we're going through right now. There's multiple paths to success. There's multiple paths to failure. Some of the failures can be catastrophic. Some of the successes can be more beneficial than others. And I think we're at that point in our nation's history where the next 5 to 10 years will determine our trajectory and the long-term longevity of our nation as a result of how we deal with this. I come from California, where we have a lot of wildfires. I'm right in the middle of wildfire season and country, right? We see it all the time. One of the failures that we're recognizing here locally is that our local politicians, counties at the state level especially, and even some of our federal representatives are not recognizing the physics of the fire triangle, and they're instead blaming climate change for the fires. Therefore, they're not investing in things like deforestation, forest management, to remove the fuels from the fire triangle, or to, for instance, invest in more large aerial tankers to actually remove the heat and BTUs from the fires once they start. And attributing it to fire or climate change rather than addressing the physics locally has actually cost us more money and more lives and infrastructure than we probably should have realized. That's one example of making poor decisions in response to a crisis, and I think we can do better in that regard. My question, I think, is for Mr. Oppenheimer. One of the commitments as part of the Paris Climate Accords is a contribution of about, I believe, $100 billion from, I believe the language is from rich countries to poor countries. How are the other nations, the other, call it 195 or the subset thereof that's responsible for this distribution of wealth program, performing relative to those commitments? I believe our nation is on the hook for roughly $3 billion. What are the other nations doing, and what is the status of that $100 billion target?
So the $100 billion target has to be understood. It was not supposed to come out of public funds, but public funds was supposed to leverage private investments in projects like developing renewable energy in countries that need a little assistance to get there, for instance, or to stimulate adaptation in countries that have barely any emissions, but who are affected by the climate change that's brought about by the emissions of China, the US, Europe, Japan, etc. So it's not like there was supposed to be a big government slug of money. That being said, there has been one assessment, you'll have to allow me to get you the reference later, which showed that actually the governments were, after a very slow start, beginning to hold up their end of the commitments. I can't tell you how much the US versus China or India, well, India probably isn't a donor in this case, the European countries gave. I'd have to look that up. But after myself being very skeptical, because these are the kinds of commitments that are rarely actually abided by, their rhetoric, the countries actually have stepped forward more than I would have expected, more than many expected. And it's that leverage on private funding that has made the program work better.
Okay, so I guess if we're not really tracking or necessarily thinking too much about the financial commitments of the Accord, how are we doing from an actual performance relative to reductions of CO2 as an organization within an agreement besides the United States?
So the latest suggests that the commitments that were made, the nationally determined contributions at Paris and in some cases shortly thereafter, are not being fully implemented. That doesn't mean that nothing's being done. It means that countries have, in some cases, put other things ahead of climate change. It's short-sighted, but that's happened. Or in some cases that the political consensus hasn't been as solid as it would need to be, like in the United States. But you can't declare Paris at this point either a failure or a success.
Understood. Thank you, Dr. Oppenheimer. If I can reclaim, I think the cost estimates of us remaining in the Paris Climate Accords are $3 trillion to our US GDP and will ultimately cost us 6.5 million jobs. I think this is one of these decisions we do need to look more closely at. There may be other alternatives to get to success that are actually more beneficial to the climate and our economy. Thank you. I yield back.
Mr. Byer is next.
Thank you, John, very much. And Madam Chair and Ranking Member Lucas, thank you very much for pulling this together. This is the existential crisis before us. And with respect to the trade-offs, we traditionally underestimate our existential threats. All the psychology research shows that, and that's what we have done for far too long. Dr. Housefather, you mentioned how even if we get emissions all the way down to net zero, global temperatures aren't going to fall for many centuries to come. If we're going to actually reduce global temperatures, we need net negative emissions, sucking more CO2 out of the atmosphere than going in. We've been looking at a number of these different net negative technologies, but can you talk about direct air capture and the scale of their deployment?
Sure. So direct air capture is one of the most promising negative emission technologies on the table, in part because it has the ability to capture a large amount of carbon using a fairly small amount of land area. The other technologies that we look at, like bioenergy with carbon capture and storage, have a huge land footprint and involve huge trade-offs with land that would otherwise be used to produce agriculture, which can lead to additional deforestation if it pushes that into other areas. But direct air capture is essentially using chemical compounds to bind with the carbon in air that's pumped through a large device and produce a solid sort of calcium carbonate type output that then can be easily buried and sequestered underground. The challenge with direct air capture is it is very energy intensive. It requires a lot of energy to run these machines. We would need many hundreds, if not thousands of them to make a big dent into global emissions. And because they're very high capital cost, you really want to have a high operating capacity factor for these devices. And so a world where, say, we have lots of extra solar during the day, using that extra solar to run direct air capture is great, but it doesn't make much economic sense unless you can run these devices close to 24/7. And so there's been a lot of discussion around, potentially tying them to new advanced nuclear reactors, or ensuring that the larger grid is decarbonized by the time we deploy these at scale, because we don't want to be using energy that releases CO2 to capture CO2 from the air. Otherwise, we're not really making much of a benefit at all.
Thank you. My hometown's Alexandria, Virginia, and we suffer nuisance flooding. And of course, I'm in Virginia with Norfolk and Virginia Beach, which seem to be underwater half the year. And the coastal resilience is so incredibly important. We have the National Ocean and Coastal Security Improvement Act just to try to prepare this. But Dr. Oppenheimer, can you touch on how we need to proactively take higher sea level rise into account and why it's so much more important to be proactive than reactive on this?
Well, just to get to nuisance or sunny day flooding, that's become a real nuisance around the country. It was a very rare occurrence where people actually lived or where infrastructure existed, if you look at the data from 50, 60 years ago. And it's gradually increased, and that's strictly because of sea level rise. And so communities, parts of the city I live in, New York, parts of Miami, parts of other places are starting to see this gradual problem go from 1 or 2 days a year to 30, 40, or 50 days a year. And you can't defend against that instantaneously. The things that need to be done are, by and large, decisions which are politically difficult, like deciding that certain areas aren't going to be habitable anymore, and the cities or countries or towns can't afford to keep up infrastructure, or that and you move people out, or that you pay you find a way to have people afford to raise their houses, which isn't a very pleasant, but is sort of a short-term and temporary palliative. Two, building large infrastructure the way that the Dutch have all over the country, or way that New Orleans, the federal government has done in New Orleans, where the has gone in and reshaped the city. You can't make that kind of decision today and do it tomorrow. The planning takes 10, 20, 30 years, and the thing doesn't get built until the planning, the political consensus, the finance, and the construction are done. And in the case of a big project, that's 30 years. So if we want to worry about the storms that are now once in 100 years happening once a year in 2050, we better get going on it.
Thank you, Dr. Oppenheimer. And to my Republican pals on the call, and all who have, the mandate to defend the fossil fuel jobs, we need to be thinking about what happens when fusion energy comes and the displacement effect that's going to have on all these things. With that, Madam Chair, I yield back.
Mr. Baird is next.
Well, thank you. And thank you, Madam Chair and Ranking Member Lucas, for holding this session. I want to bring in the perspective of agriculture, and in that, I include the forest industry, but I understand that we need to invest in clean energy and solutions in climate change. But I think we ought to go beyond those that just seem overly idealistic. And so Ranking Member Lucas suggested that we invest in those science-based innovations that improve our ability to produce energy more efficiently. So agriculture, we have a similar conversation about the intersection of agriculture and climate change, highlighting the important contributions that farmers and ranchers can do to help mitigate the impacts of this climate change. One of the most interesting contributions that I found very striking was the fact that 46% lower carbon emissions if we use ethanol. And then I want to attach to what Mr. Garcia had to say and Mr. McNerney had to say. When you look at forest land and hardwood products, urban trees, they can collectively offset more than 11%, or about 3/4 of a gigaton of CO2 per year. And that's about 14% of the CO2 emissions. So my point to you is that we have a lot of things taking place in agriculture. And Representative Garcia mentioned that we are not practicing forest management in a lot of our public lands out west. And that contributes to a lot of more BTUs when we do have a fire. So these are things that we can do immediately. And so I am just interested in the witnesses' comments about using those things that are in place now and how we might invest more dollars in research, more dollars to incentivize farmers and ranchers and forest owners to do management practices that capture carbon in the soil or capturing carbon in the trees. My data would suggest that trees capture almost 0.6 of a metric ton of carbon per hectare per year. So I'll turn it over to the witnesses and would appreciate your comments about how we might use these existing systems, natural systems, to help us with helping affect climate change. And I guess I might start with Dr. Bontempi, because you mentioned that carbon is captured in cold water or ice and sinks out in the ocean. So let's start there, and then if we have time, we'll have other witnesses comment.
Yeah, thank you. I appreciate the opportunity to respond to the idea of carbon capture on the land. You know, I think one of the things that we have to be conscious of in this regard is, you know, people on the land, farmers, agriculture, are familiar with things like droughts, the wildfires that were already mentioned, and a few other phenomena that have been occurring at the extremes as we've been discussing. And these have a huge impact. And these climate extremes have been discussed by some of the other witnesses as well. It is true that trees or anything that photosynthesizes takes up carbon dioxide and goes through that process and can release oxygen. The questions become, how effective are things like trees at permanently storing that carbon? How long does it take to get back in the atmosphere? These are areas of active research, not only in observations, but in modeling. And of course, the Earth isn't infinite. How many trees do we have to plant to actually have an effective drawdown of the deltas that we need in the atmosphere to make it a long-term storage solution? So I would think at this point, I would defer to some of the other witnesses to respond if that's acceptable, because they have a bit more experience with that carbon drawdown and permanent capture on land.
Yeah, if I could add to that, you know, reforestation is one of our best, most cost-effective ways at sequestering carbon and using nature instead of our energy to do most of the work. At the same time, even if we were to plant 1 trillion trees worldwide, it would only offset about 8 years of current global emissions. And so it's an important part of the solution, but we need to make sure that we keep it in context and don't sort of treat it as a replacement for ultimately reducing emissions. Agriculture is also an area where there's huge potential for building out soil carbon. I can send around a paper I published in 2018 that covered some of these approaches, but it's an area that we need to give more support to farmers to pursue.
I see I'm out of time, so I would be very interested in the other witnesses' responses, but Madam Chair, I yield back.
Ms. Ross is next.
Thank you. And thank you, Madam Chair and Ranking Minority Member, for for having this hearing. It's so important, and it's particularly important for my home state of North Carolina, because we've seen the effects of sea level rise on our coast. We have a highway, Highway 12, that's underwater frequently, and we are building bridges and trying to beat that back. And then we're also number 2 in solar in the country, and we're dealing with issues of how to get that energy resource on our grid. My first question is for Dr. Oppenheimer, and I want to build off of some of the things that Mr. Beyer was talking about how to incentivize local governments to use research. So it's clear that we want to know what's going to happen with sea level rise, though my state legislature in the past hasn't always wanted to know. But once we have these tools, and we know it's hard to make those political decisions and it's expensive, what could the federal government do to incentivize local governments to take the necessary actions to protect people and to protect property?
Thank you for that question, Representative. There have been discussions for years of developing at the federal level a climate services, sort of like the Weather Service, to turn this information into something that's practical and that can get into the hands of the decision makers that need to make the decisions. Now, I don't know if that's the right answer, but it may be, but it could be done in cooperation with similar sorts of structures at the state and local level. The interesting model is the agricultural extensions, which for over 100 years have developed local solutions for farmers operating in particular states, in particular areas, working through local universities, for instance. And in that way, it's a national network of information, which is designed not for the elite level, but for the people who actually use it. So this is something that is doable, that probably isn't that expensive, and the states and the federal government together should get on it.
Well, thank you very much. And thank you for saying it wouldn't be that expensive. expensive. That's very attractive. I have a question for Dr. Housefather about the grid. So North Carolina is #2 in solar. I've actually represented a number of renewable energy companies. I did that in private practice as an attorney. And what we're learning is, now we have these cheaper solar resources, but the biggest issue is interconnection. And who is going to pay for that interconnection? And then who is going to pay to upgrade the grid? And I know that FERC has a cost sharing model. Different states are then left to their own devices for the model. And frequently it's the renewable energy company that has to pay for those upgrades. And those upgrades, though, end up redounding to the benefit of the utility when it comes to dealing with rates. And so I wanted to know whether you had any creative solutions about how we might do this, not just state by state, but on a national scale.
So I think there is a real role for direct federal spending in building out a 21st century grid for the US. And we need to recognize just how important it will be to enable the clean energy transition at this scale and the speed we need. I'd like to point to a study by the National Renewable Energy Laboratory that suggested that it would cost about $80 billion to build a 21st century supergrid. It would create hundreds of thousands of jobs and would ultimately more than pay for itself in cost savings for people across the country. And in a time when there really is a need to put people back to work and when the economy is suffering, infrastructure like long distance transmission is a really important way to get boots on the ground quickly.
Well, thank you very much for that. Hopefully we can talk about that in our energy subcommittee. Madam Chair, I yield back.
Ms. Bice is next.
Thank you, Madam Chairwoman and Ranking Member Lucas, for the opportunity, and thank you for the witnesses to join us this afternoon. 30 years ago, Sandia National Labs played a huge role in developing PVC bits. They were developed and sustained through specific technology research, and they had an immediate impact on the oil and gas industry. We talked a little bit earlier about how technology plays an important role in helping climate change. These are the types of, I think, investments that we should be making to ensure that we're looking towards the future and not just focusing on what's happening today. According to the acting Undersecretary for Science and Energy, Kathleen Hogan, she said there's an enormous amount of untapped potential for enhanced geothermal systems to provide clean and reliable electricity to power tens of thousands of homes across the country. So my question, I'll start with Dr. Housefather. Is it safe to say that global economic development can rely on fossil fuel, at least in the near term, but in your opinion, when we're looking to the future, would it be better to give developing countries money to combat climate change, or the technological tools that we may be developing here in this country to reduce greenhouse gas emissions?
So I think it is important to recognize that we're not going to get rid of fossil fuels anytime in the near future. But at the same time, there's sort of an order of operations for fossil fuels, right? Coal is by far the most carbon intensive, then comes oil, then comes natural gas. And so if you look at the type of models that we developed that look at how the globe might decarbonize, you see a transition away from coal first, then away from oil, and then ultimately away from natural gas. As to your second question, I think geothermal is a really exciting area right now. I think it's in many ways in a similar position to where the fracking revolution was 2 decades ago. And diamond drill bits, which you mentioned in your opening, are actually playing a huge role in unlocking enhanced geothermal today. And so this is one of the type of technologies. Renewables are obviously another, advanced nuclear is a third, where making them cheap enough so that they can compete with fossil fuels on the market is going to go a huge way to get them adopted by the rest of the world. Direct support is important in some occasions, particularly for adaptation help. But ultimately, given the scale of the energy transition needed, particularly in middle-income countries like India and China, it's making clean energy cheap that is the single biggest lever we have to drive adoption and emission reductions by the rest of the world.
Anyone else like to comment on that?
Yeah, I would add that. Go ahead, Professor Oppenheimer.
Quickly, I'd just like to add, I fully agree with what Dr. Housefather said, with the caveat that be careful with the ordering of fossil fuels. They all have problems, and in particular, unless the leaks of natural gas out of the sort of mining, transmission, and local distribution system are dealt with, then the benefits are, particularly short-term benefits, are largely eroded.
Yeah, I would add, I really appreciate, Congresswoman, your emphasis on looking both at the present and forward in the future. And when we look over the coming decades, the world will need to supply more energy than it's supplying now, and with greater access. That's true both in the US and globally, and on the order of doubling of energy supply. To stabilize the climate system at any level will require reaching net zero emissions. That's not a political statement or a policy statement. It's simply the fundamental energy balance of the planet.
Which I don't disagree with your statement, but I think one of the challenges that we should all be thinking about is that the United States can become net zero or even net negative, but that doesn't affect the issues that we're facing in China and India with them using high amounts of coal. As a matter of fact, building coal-powered plants and increasing those emissions into the environment, which is really, causing what we're doing here to be irrelevant.
Well, all of the emissions aggregate to affect the global energy balance. So the global energy, the fundamental physics of the planet are that the emissions from wherever they are, the greenhouse gas emissions are mixed in the atmosphere and affect the global temperature and the climate around the world. So I actually am supporting your statement. The reality is, regardless of the level of global warming, to stabilize the climate system at any level requires reaching net zero. And that's more global warming than we've already had, which means adaptation will be necessary. We're not adapted to the climate change that's already happened. Further climate change will require further adaptation. The US can be an innovator and a leader in all three of those dimensions. All three of those dimensions are needed here in the US to manage climate risks. And we can do exactly what you described in terms of supporting the rest of the world through innovation in each of those dimensions.
But without a focus from India and China on this very issue, what we're going to be doing in this country won't be an impact globally. Madam Chairwoman, I appreciate the time and I yield back.
Mr. Foster is next.
Thank you. Am I audible and visible here?
Yes, sir.
All right. Well, let's see. I'd like to start by asking, maybe getting reactions to what are sometimes called Bill Gates 5 questions, and whether you think that's an appropriate way to look at this problem. His questions are, first off, for any proposed solution, how much of the 51 billion tons are we really talking about? That we want to make sure we do our research in the areas which will really take a big bite out of that, instead of sort of boutique solutions. Second question is, what's your plan for cement? By cement, he means cement, steel. The other boring ways that we put a lot of carbon into the atmosphere, but don't seem to be doing as much research toward lowering the footprint there. How much power are we talking about? How much space do we need? And most fundamentally, how much is this going to cost? This is what Bill Gates referred to as a green premium. A decade ago, this was the formalism of the McKinsey plot, where you look at the cost per dollar of carbon mitigated. And you line up just everything you might do to mitigate carbon, and you start with the ones that cost the least, and you get them done until you solve the problem. Just march down the list, which I always thought was a pretty good way of analyzing this problem. So I was wondering if any of you have a reaction to that, if that's really the best way for Congress to think about this problem, or are there holes in that methodology?
Well, let me just answer that first in this way. I think that the idea of looking at what's the big bang for the buck is, and if that's what he meant, it's a little hard sometimes to know exactly what he meant. That's in general a good principle in life. So if there are big gains that can be made against a relatively modest sector, take the gains. If there are big gains that can be made against a big sector for a reasonable cost, take that. The biggest gain that's been made against the greenhouse effect has been actually under the Montreal Protocol, which has nothing to do, used to have nothing to do with climate change. It has to do with originally with protecting the ozone layer. But those gases happen to be strong greenhouse gases. So they took off the table a lot of what's called climate forcing, and we'd be even in worse shape today than we are if that hadn't been done. So looking for opportunities where you can do two things at once is also a very smart idea. Where I have trouble with the Gates message is that it can be read as saying there are technological silver bullets if we're just smart enough to find them, and that's the role of government. And I think that's just wrong-headed. As I mentioned before to Congressman Bowman, you need a combination of appropriate support for technologies and appropriate regulation to put the incentives in front of industry to head in the right direction.
If I can add to that, I'd like to echo Dr. Oppenheimer. You know, I think we have a lot of the technologies that we need today, and we should recognize that we don't have all of them. There is a real need for continued innovation, both to drive down the cost of the technologies we have and to develop the technologies for hard to decarbonize sectors of the economy, like industrial heat, like steel production, glass production, cement production. You know, there we don't really have cost-effective ways to replace fossil fuels today. And so it's sort of a yes-and approach. And also, we do need to avoid sort of silver bullet thinking when it comes to energy technology. There is no single technology, be it renewables, nuclear, whatever, that is going to solve this problem by itself. We really need an all-of-the-above approach to clean energy, recognizing that different regions of the US will have very different resource availabilities and different requirements around decarbonizing.
Yeah. I was also struck by the difference in your testimony in attitude toward tipping points. You know, that I believe it was Mr. Housefather's observation that really, you know, as you continue to pour more CO2 into the atmosphere, it just sort of gradually got worse. There's not some magic point where positive feedbacks took over. But then on the other hand, you know, there are things like the reversal or the stoppage of the Gulf Stream that seem like they are a really scary near-term risk. That there's apparently geological evidence that, you know, in the time scale of a decade, the Gulf Stream has stopped and restarted, and indications that the slowing down may be happening now. You know, if that happens, we don't have 50 years to respond, and, you know, Scotland's going to look pretty different if that happens. And I was just wondering what your, is there really a scientific consensus on this issue of tipping points?
So there are absolutely thresholds in the climate system, and you know, some of them are known knowns, some of them are known unknowns, and surely there are unknown unknowns as well. We're seeing with you know, the large glaciers, non-linearities emerging you know, in real time. That has huge risk for sea level rise, for example. We certainly see with the effects of heat many non-linearities. We heard about the importance of agriculture earlier. There are very clear non-linearities with very steep declines above temperature thresholds, and global warming is already increasing the frequency of occurrence with which those thresholds are crossed. And this brings me to my final point, which is the importance of adaptation and research and adaptation. The adaptation gap that Professor Oppenheimer mentioned earlier is large. It's large at present, and it will grow as global warming continues. Frankly, in order to manage the risks, reduce impacts, we need further research in how to design, develop, and deploy adaptation solutions at scale.
Thank you. My time is up, and yield back.
Mr. Feenstra.
Thank you, Madam Chair and Ranking Member Lucas. Before I start, I just want to thank each of the witnesses for their testimony and sharing their extensive research and opinions with us. Dr. Housefather, in my district, Summit Carbon Solutions and Little Sioux Corn Processors are teaming up for a carbon dioxide capture and storage project. The partnership aims to capture 444,000 tons of carbon annually, which will lower the refinery's footprint. It will also be part of an infrastructure network with other biorefineries that will have the capability of capturing 10 million tons of carbon annually. Will large-scale partnerships like this be crucial to achieving significant lower carbon emissions And then number two, they cited 45Q tax credits as being crucial in allowing their companies to invest in these technologies. Could you comment on what types of current or new incentives would help encourage this type of carbon reduction and capture?
Sure, I'd be happy to. So carbon dioxide removal is a critical technology to meet the climate goals we have today. Both because there are some hard to decarbonize parts of the economy where it simply is going to be the most cost-effective solution to capture the carbon from fossil fuels rather than replace them with something else. And because, as the other witnesses have discussed, we may want to reduce our global emissions below zero in the future, and we need these sort of carbon capture technologies to be able to do that. And so I think we definitely need to be investing more in these than we are today. In terms of the types of things that can help, one big one is just long-term certainty, and 45Q goes a long way to doing that, to make sure that these companies know there will be a market for the carbon that they are capturing, so to speak, a price that's being paid to them. The second is more of an investment in the supporting infrastructure around carbon capture. Capturing the carbon itself is in some ways one of the easiest steps. Then you have to actually have pipelines associated with that. You have to have long-term geological storage that's proximate. And so making sure that we invest in those infrastructure as well can really enable carbon capture to scale. Now, carbon capture is not going to be the solution. Obviously, a lot of sectors, it's going to be easier to replace fossil fuels with clean energy sources. But certainly for some sectors, it will be a big part of the solution.
Oh, okay, so let me just expand on that a little bit. So carbon capture, especially with biorefineries, we can get down to a net negative. With biofuels, this seems like the greenest form of energy, and yet there's this agenda of pushing electric vehicles, which in itself has a lot of problems with, creating batteries and all this other stuff. How do you see biofuels then playing out in this greater plan of reducing carbons?
So today, the dramatic cost declines we've seen in batteries have really unlocked a powerful electric vehicle market for light vehicles. But I think there is, an important role for biofuels, both for some light vehicles, and we'll see how those end up playing out in the market. It depends a lot on what happens with these technology costs going forward. But also for things like heavy-duty transport over long distances, where limitations of batteries make that a bit more costly and more challenging, and especially for things like long-distance shipping and aviation, where using electricity for those transportation purposes are possible, but very, very difficult. And so, biofuels are an important part of the solution as well. We do need to be cognizant of the impacts of growing biofuels if they're offsetting other activities. If you're pushing, say, more deforestation in Brazil by reducing agricultural output in the US by devoting a lot of land to biofuels. We're not really there today, but those secondary effects do need to be considered when looking at impacts of biofuels. But I agree that carbon negative biofuels through carbon capture and storage is a really exciting technology. And it's one that is used at an extremely large scale in a lot of the energy system models that are used by the IPCC to model some of these emission pathways.
Thank you, Dr. Housefather. I look at it this way. I am in the Midwest in Iowa, and we have this corn kernel, or we have this soybean that holds energy, literally holds energy, and we squeeze and we get the energy out. So to me, it's one of the greatest forms of energy, clean energy that we can use. So with that, I just want to yield back. Thank you.
Mr. Caston is next.
Thank you so much, and thank you to our witnesses. I'm really just so pleased to be here with all of this climate science expertise and geological science expertise. And I want to get to questions about climate science, but I just want to raise a concern. There's been a lot of conversation in this hearing about economics and energy technology. And as someone who spent 16 years building and running clean energy companies, there have been some gross misrepresentations, and I just want to clarify a couple things. Number one, clean energy is cheap energy. Anything we do to replace something that uses fossil fuel with something that uses a renewable source, with something that's more efficient, is a source of cheaper energy. It grows our economy. It makes us wealthier as a people. Any conversation we're having about the conversion to a clean energy economy being economically painful is at best economically naive, and at worst immoral. It's sacrificing a cheaper, cleaner future to look after the fossil fuel industry. The reason those projects aren't deployed is not because of technology. because our regulatory structure grossly distorts economic markets and subsidizes incumbents, because ultimately this transition represents a wealth transfer from energy producers to energy consumers. Let's have that conversation, but let's not misrepresent this. Now, I want to shift to climate science, and Dr. Oppenheimer, I really, really appreciated your comments about the lag time that happens between when we emit greenhouse gases and when the effects take place. And what I wonder if you could help us out with is I want to just paint a completely over-optimistic view of the world. Let's say we eliminate all CO2 tomorrow. Explain to us, if you could, what the lag time is before we stop seeing, before that curve saturates. How much more are sea levels going to rise? How much more intense are the derechos in the Midwest going to get? How much more intense are hurricanes going to get before we saturate that curve? Can you speak at all to what your models tell you about that?
Well, if you mean if we eliminate all CO2 emissions, as opposed to all human-made CO2 that's already been put in the atmosphere.
Yeah, just on a going forward basis. So what we already have.
Yeah. So that's certainly been looked at, and one of the lower conceivable emissions curves was the consequence of that for sea level rise was examined in the report that I had a hand in on oceans and ice, which was mentioned by Paula earlier. And the reality is that the sea level rise you get over this century and beyond is a lot lower than if you just let emissions keep going. I mean, we're talking about meters difference in sea level rise. But nevertheless, by the end of the century, in any conceivable emissions scenario, we're going to have to deal with somewhere between a half a meter and a meter of sea level rise globally. Let me back up. Actually, what I said was not correct. Over the next few hundred years, we're going to have to deal with a half a meter to a meter. That's because of the very long lags in the system that you asked about. Over this century, we might wind up below half a meter if we're lucky, and that would be, not great, but it's a safer landing than if we're at 2 or 3 meters going to 2100 and beyond.
I appreciate it, and the fact that even in a best case scenario we're looking at sea level rise measured in feet. I just think we need to internalize that when we think about what we're doing. Now take, and you correctly sussed out, take the even more optimistic scenario. Let's say we actually not only got to zero CO2 tomorrow, but invested in all of these negative carbon technologies and got back to, I don't know, something sustainable in the 350 parts per million zone. Are there hysteresis effects as we go backwards, or what's the lag time if we get back to where that is? Do we anticipate, at some point an end to wildfires and a heightening polar ice, or are some of these changes just fundamentally irreversible at this point?
Yeah, there are irreversibilities. For instance, the amount of water that we lose from the ice sheets into the ocean because ice melts or forms icebergs, we're not going to get that back. We're not going to get it back for 100, 1,000, maybe 10,000 years. We may not get it back until we go into another ice age. Who knows how long in the future? So yeah, there's some very serious irreversibilities. And number one in that is whatever amount of sea level rise we gain from losing ice from Antarctica, Greenland, and mountain glaciers, we have no way to haul that back.
There's no time constant that we start to see greater snowpack and temperatures falling? Is that not in the planning horizons?
You wouldn't be able to rebuild enough, given what we know. I always want to be careful about the uncertainties. Given what we know, the restoration time for ice is in the thousands of years. Wow. So we're not going to be building back a lot of that ice in human lifetimes. Let's put it that way.
Wow. Thank you. And I yield back.
Mr. Obernolte is next.
Well, thank you, everyone. It's been a fascinating discussion. I'd like to further the conversation that we've been having about how we shield disadvantaged communities against the economic effects of transitioning to net zero carbon. And this is something that I know Congressman Lucas mentioned, Congressman Posey, Congressman Bice. And so, Dr. Housefather, if you said something that I thought was really fascinating. You said that we should be able to get to a place where clean energy is just as inexpensive as the energy we've been producing, that's carbon intensive. And I'm wondering, how we get there, because in California, we've got a very stringent renewable energy standard that, has caused residential electricity rates in California to be double that of adjacent states. And that's one of the reasons why California has the highest poverty rate in the nation. When you factor that in, is those energy costs. So how do we get, what are we doing wrong here? How do we get to the point where these disadvantaged communities aren't being affected by higher energy prices, and where energy costs aren't driving poverty as they are in California?
So that's a great question. California is a complicated system. Energy generation costs in California have actually been going slightly down for the last decade. The transmission and distribution costs have been going significantly up. Some of that is related to grid expansions to support more renewable energy on the grid. Some of that is related to dealing with the state's wildfire crisis and various grid hardening activities around that. But more broadly, there are certainly cases where there are costs to an energy transition. And those costs can be disproportionately felt on poor people, particularly if electricity prices or gasoline prices are going up. For people who have to commute to work every single day, multiple hours, gasoline prices can be a large part of their disposable income. And so we should make sure that in any climate policies we're implementing, be it a carbon price, be it a subsidy for a particular type of energy, we make sure that we are not disadvantaging the people who are the worst hit by that. So as an example, if we were to ever put a price on carbon, it would make a lot of sense to make it revenue neutral in a way that makes sure that the people for which energy costs are a larger portion of their income, gain from it, they don't lose from it. Another example is, making sure that when we are switching over from one source of energy to another, we provide considerable assistance to those communities that will be most impacted through the loss of jobs in that sector, or through broader disruptions to local tax revenue and other factors like that. And so we need to start planning ahead. Coal country in many ways can be a cautionary tale here, right? Because technologies can disrupt our energy system very rapidly, be it natural gas and wind displacing coal, electric vehicles reducing oil demand and reducing production in parts of the US in the future. We see a lot of these things coming, and we need to better understand which communities will be worst affected and plan ahead to make sure that they're not left behind.
Sure. Thanks. I think you raise an excellent point about, the economics of carbon pricing. But I just want to raise as a cautionary tale, the fact that political reality intrudes. And when we have tried in the past to try and use that pricing to reduce the impacts on disadvantaged communities and consumers, as we have in California with the cap and trade system, it ends up being a giant government piggy bank. Those benefits actually don't make it back to the consumers if we're not careful. And then one last question for you, since I've got you, Dr. Housefather. You also mentioned that you thought it was possible to get to a net zero energy mix. What I'd like to ask about is baseload, because all of the estimates that I have seen indicate that storage, when you're talking about just renewables, storage is never going to get us to the point where we can provide baseload without some kind of non-renewable source. So, what kind of mix can we do that with?
So that's a great question. When we look at storage, where storage really excels is bringing power from, say, the midday when you have a lot of solar on the grid to the evening when use ramps up. The challenge you face, though, is around seasonal differences in generation. In California, for example, our solar panels produce half as much electricity in the winter than in the summer, whereas our demand is only 20% lower in the winter than in the summer. And as we electrify the economy, as we start replacing natural gas furnaces and water heaters with heat pumps in homes, our winter demand is going to increase even more. And so there is a real need for clean, firm generation on the grid, be that gas with carbon capture and storage, be that advanced nuclear, be that enhanced geothermal, where there's a lot of really exciting developments. But as I mentioned in my written testimony, energy system models that include a chunk of clean, firm generation tend to be lower cost overall than ones that rely just on variable renewables and storage.
Sure. Yeah, I completely agree. And especially clean nuclear, I think, is something we can't ignore. All right, I realize my time is up. Thanks very much, everyone. It's been a fascinating discussion. I yield back.
Mr. Kildee is next.
Thank you so much. And for the witnesses, thank you for a really interesting conversation thus far. I'm sure many of you know, at least committee members know, I come from Michigan, a state with a really proud heritage of making automobiles, putting the world on wheels. And even we in this area, in this sector of the economy recognize that this climate crisis is real and we have to address emissions. It's a huge polluter. The transportation sector in particular is the largest contributor to climate change. And so American auto companies have been working to transition from internal combustion engines to electric vehicles. For example, General Motors, which by the way was founded right here in my hometown of Flint, Michigan in 1908, GM has invested heavily in electric vehicles and is committed to stop selling internal combustion vehicles by 2035. And I have been working to expand the 30D tax credit that would provide consumer incentives to purchase electric vehicles. And just to be clear, to expand it in a way that makes more affordable vehicles available to more people across the economic spectrum, especially folks who are middle income earners. Some opponents to electric vehicles, however, say that much of the electricity used to power electric vehicles is made from fossil fuels that generate the electricity, fuels such as coal and gas. So starting perhaps with Mr. Housefather, can you talk a bit, number one, about how electric vehicles can help decarbonize the transportation sector, even when electricity, at least for now, is primarily generated using fossil fuels, and just talk about the efficacy of continuing to invest in EVs.
Sure. So even today, if you get 100% of your electricity from coal, which nowhere in the US does right now, an electric vehicle would still be slightly lower carbon than the average conventional vehicle on the road today. So that's the starting point. Now, the US grid is much cleaner than that today. And so you can expect at least 50% reductions in life cycle emissions for electric vehicles today in most parts of the country. That includes, taking into account the emissions associated with producing the battery, which is non-trivial. That said, the real benefit of electric vehicles as a tool of decarbonization is they get better the further along we get in other sectors of the economy. So as we decarbonize the grid, the use emissions from those electric vehicles goes pretty close to zero, and the manufacturing emissions also decreases pretty dramatically. About half of the emissions required to produce the batteries for electric vehicles is in the form of electricity used for the assembly of the battery pack. The other half is for mining, transport of the materials, et cetera. And so as we reduce the, clean up the grid, we're also going to decarbonize the manufacturing process for electric vehicles.
You said something just in the last question that I just wanted to follow up on, because it's been an area of real interest for me, and it has to do with the use of geothermal. Can you talk about how geothermal might be used? Because I know this issue of surge and the imbalance in particularly in consumer demand for energy is one of the real challenges when it comes to energy storage. But it seems to me, and I've thought about this in the context particularly of urban redevelopment in low-income communities, that the use of geothermal not only can reduce consumption, but actually reduces some of the inequity or the problems that we have in terms of imbalance in utilization. Can you discuss whether or not you think there's reason to invest in research around how geothermal might be used to promote affordability of energy?
I think there is. When we talk about geothermal, we should really differentiate between sort of ground source heat pumps, which is sort of small scale geothermal for homes, and sort of enhanced.
Yeah, that's really the focus that I'm trying to zero in on.
Yeah. So those technologies are still fairly expensive today in most places, but costs have come down a lot. It certainly is a very promising area to continue, research and development and deployment in. I'm less familiar with it than on the power generation side, to be honest.
Well, I appreciate all of your testimony. I appreciate the chairwoman holding this really important hearing. Thank you for that, and I yield back.
Ms. Kim is next.
Unmute.
We can hear you.
Okay, thank you so much. I want to thank our ranking member Lucas and Chairwoman Johnson for this very informative hearing today. The communities that I represent in California's 39th district are keenly aware of the climate change impact. Every year, our region is devastated by record-setting wildfires caused by increasing temperatures, costing our taxpayers billions of dollars. But rather than looking for a centralized government response to climate change, like Green New Deal, our country should look to unleash market-based solutions. If our country does not take the initiative to implement innovation and new technologies to combat climate change, other countries like China will take that initiative away from us. You know, Mr. Housefather, in an LA Times article, you noted that fires are not unusual in California, that they are part of the state's history and landscape. But bad forest management combined with human behavior have contributed to the problem. And as my colleague from California, Mr. Garcia, also mentioned, wildfires are a problem in California. So let me pose this question to all witnesses. Can you talk to us about the role of forest management and land use play in climate change and emission reduction? And do you think that the monitoring of wildfires by using satellites and the National Weather Service, along with forest management, would help in preventing some of the tragic effects we've seen from these large fires?
Yeah, I can start. Wildfires result from a confluence of conditions, as you've described. There's certainly never been a wildfire without ignition. There's never been a wildfire without fuels. There's never been a structure threatened or destroyed without habitation. So these all contribute to wildfire risk, and we know that we have opportunities to manage those risks in each of those dimensions. So absolutely, how we manage fuels is critical. The resources that we have for fire prevention and response are critical, as we've seen tragically in recent years, including this past year. The state of the electrical grid, which has been a source of ignitions in California in recent years, is critical for reducing ignitions. And the reality is that the condition of the fuels is being affected by global warming and the associated climate change. The area burned in the Western U.S. has increased around tenfold in the last 4 decades. About half of the increased area burned is attributable to long-term warming and the effect on fuel aridity. My research group published a study this summer documenting that the frequency of extreme wildfire weather in California during the critical autumn season has more than doubled in the last 4 decades. So we're in a climate now where high risk is more common, it's more frequent. That will continue to accelerate. We've seen tragically year after year the effects of this elevated risk that has stretched our response systems past the ability to prevent those fires, to contain those fires, and to prevent the loss of structures and tragically the loss of life.
Thank you. I'd like to reclaim my time so I can put in another important question in there. You know, the United States has the most dynamic private sector in the world, with entrepreneurs, investors, big companies, and capital markets all eager to license technologies and launch startups. But many of these ventures are built on technologies that come from basic research funded by the federal government. So can you talk about some of the examples of sustained technology-driven research and development the government has started and the private sector has commercialized successfully?
I'd be happy to take that really quick. So, pretty much every technology that we're using to decarbonize our economy today has its roots in federal and state R&D efforts, be that solar photovoltaics, onshore wind, cheap natural gas, which is one of the biggest factors displacing coal in the US today. Geothermal is really being powered today by diamond drill bits and horizontal drilling and hydraulic fracturing technologies that came out of federal investments. The federal government has invested significantly in battery storage technologies in the past, and R&D there, and our national labs have played a key role. And so I think that, we really need to recognize the power of technology to help us tackle climate change, and at the same time, the critical role of the federal government in driving that forward.
I think my time is up. I yield back. Thank you.
Ms. Moore is next.
Well, thank you so much, Madam Chairwoman and Mr. Ranking Member. Of course, this is just like being in school. I've learned so very, very much today. I am not that efficient with managing my time, so I'm going to get right into it. And maybe I'll start with just mentioning something. I realize I'm not from Flint, Michigan. But I am from Milwaukee, Wisconsin. It's one of the Great Lakes, and I just want to mention that if the Great Lakes were a country, it would be the third largest country in the world. It brings $6 trillion a year to our economy, and of course, Wisconsin, we are the biggest trading partner with Canada, and 3 million of that trade passes through Wisconsin. I say that to say is we spent an awful lot of time talking about disasters on our coasts and, New Jersey and New York and the state of Washington and California. And I just want to remind people that, we're the fresh coast, and we have a huge economy to protect. And I'm wondering, maybe from Dr. Oppenheimer, you do a lot of stuff with attribution. Is there any different sort of climate research that needs to be done to maintain and sustain the Great Lakes? I know that the Army Corps of Engineers right now is engaged in a climate resilience project, but they often just get involved with hazard mitigation when, utility lines are knocked down or something happens. Are the Great Lakes being neglected in the whole scheme of things?
Well, I wouldn't say they're being neglected. The hottest temperature ever recorded in the United States, taking together heat and humidity, it's called the wet bulb temperature, was recorded in Appleton, Wisconsin. So, extreme heat affects the whole Midwest, right up the Mississippi Valley and spreads out. And we know that, and there's been no less focus on that. And it's a real concern, even in the most northerly regions of the lower 48 states. The agricultural economy, which is so important in states around the Great Lakes, is a focus of a lot of study. In fact, there's a study I carried out, which isn't completed, which tried to demonstrate how many people move in and out of those counties if it gets too hot and the corn doesn't tassel and people start moving elsewhere. And there have been
I would love that study. I got a couple more questions, but I would love to see that. Sure. I just want to ask a question of maybe Ms. I just want to appreciate our witness who has served on the Native American with the Native American lands. I want to ask her if she has seen that climate satellites are useful in monitoring climate, and what does she think that might do in creating, I think, a raison d'etre for investing in vulnerable communities and low-income communities to demonstrate, maybe by attribution, the benefits of reinvesting in those communities without gentrification to ward off the greatest climate damage.
Yes, ma'am. Thank you so much for that question, Congresswoman Moore, forgive me. I would say satellites have been absolutely instrumental in enabling us to identify long-term trends in climate variability and change on a global scale. What they also allow us to do is reach down to the regional and local levels and actually look at direct impacts of climate variability and change on different populations, particularly along the coast. You mentioned the Great Lakes. We study, harmful algal blooms in the Great Lakes, water quality in the Great Lakes. This is really important. And I also know, and the IPCC points out, that these communities are disproportionately impacted by climate variability and change. There are agencies that study this. NASA has an applied sciences component to its Earth Science Division. Our colleagues in NOAA, others with real management responsibility, take a very hard look at utilizing all pieces of information and blending that into transitioning research into management strategies that can support these communities. The system isn't perfect, and there's a lot of research to do, which is why I stress the hand in hand of research and management.
Well, thank you so much. I have, 5 or 6 seconds left. I just want to, support the comments of Mr. Caston and say that we ought not pit money and the lack thereof, against our efforts to mitigate climate impacts in vulnerable communities. And I yield back.
Ms. Stevens is recognized.
Great, thank you so much. Allow me to just say I'm from another Great Lakes state, Michigan, and I love what Congresswoman Moore just laid out. I also just absolutely loved these testimonies, and I want to thank you all for bringing your expertise to our committee, and breadth of knowledge and fact and figure and designation for us today. In particular, Dr. Housefather from the Breakthrough Institute, you provided just a very thorough write-up of what I soaked with your materials, and one I want to recognize, and I know Mr. Caston and Dr. Foster appreciate, and certainly our chairwoman who saw this through to the finish line, which was that you, on page 31 of your testimony, you mentioned the sweeping bipartisan package that we got done that authorized billions of dollars for investment in clean energy, vital energy R&D, grid modernization, and on. And I loved how you put in quotes this, that it's the potential for quiet climate policy, but a big thing on this committee is how we work together and produce, and I've spent some time with Sean Caston on this, Congressman Sean Caston, and how this was really just a sweeping effort and just part of what we're trying to do. But I appreciated that you included that in your testimony, sir. And you also mentioned a couple other things. One, I know that Congressman Kildee has talked to you about the electric vehicles here in Michigan. I'm in the heart of automotive land here. We are already seeing industry prepare and get ready for the arrival of electric, certainly the global demand. We got a lot to do on the infrastructure side. But you, sir, mentioned peak oil in your several times in your written documentation. I was just wondering if you could give me your definition of peak oil and what you mean by that, and also what that means for those of us who are in this manufacturing space, plight towards sustainability, and what we should expect in terms of when we're heading peak oil.
Thank you. That's a great question. So when I refer to peak oil, I'm not really talking about the peak oil concerns of the 1990s, which was all about running out of cheap oil. Clearly that was very wrong. The world has plenty of cheap oil. But rather I'm talking about peak oil demand, the point at which global oil use stops increasing and starts decreasing, which is something that seemed out of reach a decade ago, but now seems pretty close to happening. British Petroleum has already predicted that 2019 was the year of peak oil, and that will never recover to that level, even in a current policy world without, rapid additional climate policies. Other groups suggest that it'll more plateau around current levels or slightly increase into the future. So there's by no means universal agreement on this. But certainly if you look at government targets, it would imply that we're going to either reach peak oil last year or in the mid-2020s at the latest. And if you look at manufacturer targets, so what companies have pledged to do in terms of their EV sales globally, we'd reach peaking oil even sooner and see larger declines. And so, I think we need to start preparing for a world in which the rapid falling price of electric vehicles is driving down global oil demand. It's not going to eliminate all of it anytime soon, but certainly we're not going to be seeing a world of rapidly expanding oil use that's characterized the last few decades. And that has important implications. One of these is that in a demand-constrained future, it's really going to benefit the cheaper producers. Places like the Middle East, which have very low marginal production costs of oil, will be able to capture more of the market when the market size overall is shrinking. And that means we need to be prepared. Obviously, we can't predict the future perfectly. Things might change. Global oil demand might increase, driven by much more rapid economic growth than we all forecast. We simply don't know. But we should prepare for a world in which relatively expensive locations of US oil production become less economical and prepare for the types of disruptions that might happen there.
Well, and we got to ask ourselves too, in terms of some of these transformations, because you look at peak oil into the plastics industry, certainly, or even, we talk a lot about electric vehicles, but I haven't yet heard about the electric plane, but right. And we can look at, what's relying on the fuel and the plight, and you very nicely articulated, and all of you, by the way, these testimonies are just, I could spend 10 to 15 minutes with each of you, and I'm going to do some follow-up questions because I'm on time. I've hit my time, and I want, Zeke, I wanted to get to this agriculture point that you brought up. We've got, obviously you're talking about the carbon use on agriculture, as well as, these notions of a world without ice. So if that's okay, I'll just do those for the record, and I'm going to yield back to, the next person in line. But this has just been a remarkable hearing, so thank you all.
Mr. Lamb is next.
Thank you to the witnesses for sticking around this long. I wanted to start with Dr. Housefather as well. I know that you had done a little bit of work in the past on the transition from coal to natural gas and the, I guess, percentage of methane leakage that you need to make that advantageous for climate change purposes. Could you say a little bit about that research and where the industry is now? And this is like the most compound question ever, sorry, and also reinstating the methane rules that were in place before the Trump administration repealed them, what that would contribute to this issue of ensuring the climate benefits of the transition from coal to gas?
So that's a great question. The comparing methane emissions from natural gas to CO2 emissions for coal or natural gas is really complicated because methane and CO2 are very different greenhouse gases. They have very different lifetimes, they behave differently. And a lot of it comes down to how much you value sort of short-term effects on the climate versus long-term effects on the climate. That said, in almost all scenarios, natural gas is not worse than coal under the types of leakage rates we have today. And if you look at the long term, you'd have to have much higher leakage rates than anything anyone is suggesting we have today to make it worse than coal. But worse than coal is a really low bar, right? We need to make our energy system considerably better than coal. And there's huge potential in tackling leakage from the oil and gas sector. There's no reason why companies should be losing 2% of what they produce to the atmosphere. It means they're losing money. It means it's, harming our climate. It has significant local air pollution impacts. And so better understanding where these leaks are coming from, which involves satellite monitoring, which involves a lot of newer technologies like infrared cameras on drones, for example, which can do a good job of detecting methane leaks. Like there's a huge amount of technology that can be thrown at this problem effectively. What we've also found, and the work by Adam Brandt, Dr. Adam Brandt at Stanford has been really instrumental here, is that the leakage in the system is dominated by a long tail of what we call super emitters, a small number of sites that are responsible for a large portion of our overall leakage. And so remote sensing can provide an important detection mechanism there to let us narrow down on those sites. And those super emitting sites are usually places where the operator of the site does not know that a leak is occurring and could really save money by remediating it. And the real cost there isn't so much fixing the leak, it's detecting the leak. And our efforts should really focus there.
Now, it sounds like though that prescription has a lot to do with technology and deployment of technology, which is good. But are you familiar with what the methane standard was before the Trump administration sought its repeal? It had to do a lot with the frequency required of inspections, but I guess what I'm trying to get at is, would a replacement of the status quo ante help put us back on the road to something like less than 1% emissions, or does it have to be a more technical and rigorous standard going forward?
I mean, I think inspections are a critical part of getting to the bottom of the problem. At the same time, we want to try to minimize the cost of these inspections as much as possible. And I think that's where technology plays a role. So I think it's a combination of both. And also creating systems. And I think Colorado has really led the way here in some ways of, creating smart inspection regimes where if there is a problem, you get another inspection relatively soon after that, maybe next year. If there's not a problem, it might be 2 years or 3 years to get your next inspection, and you have to pay the costs associated with that. And so, rewarding companies that do a good job, penalizing those that don't, and ensuring that we can get to the bottom of where these leaks are occurring on the production side. Now, There's other challenges around distribution, particularly last mile distribution, where it's much harder to mitigate leaks. And there, we're ultimately going to solve that by moving away from natural gas toward things like heat pumps for space heating and water heating.
Great. I have a minute left. Any other witness want to be heard on those couple of questions?
Yeah, let me just add that there's been a tremendous amount of research done in the last 10 years in identifying the sources of the leaks, and particularly in the few years since the Trump administration started taking apart the regulations, we know a lot more now, and so I think it's going to have to be looked at again carefully, because in answer to your question of exactly whether the past regulations were what we needed, were they strong enough, I don't think we'll know that until there's a thorough review. So just reinstating those regulations might not be good enough at this point.
Well, thank you for that, and thank you all for sticking with us this long time and for your insights. And Madam Chairwoman, I yield back.
Ms. Wild is next.
Thank you so much. This has been a really interesting hearing, and I appreciate it. I wanted to ask a question. I'm going to start off with Dr. Diffenbaugh. I share with my colleagues, we've all shared stories of our own districts and how climate change has affected them. And my district is Pennsylvania 7, the Lehigh Valley. And based on a 2018 analysis, NOAA data shows that it is the fastest warming area of our state. And our community sits on the edge of floodplains. I've seen firsthand recurring flooding. We are being hit constantly by stronger storms and heavier precipitation, which of course stresses our local infrastructure and damages people's homes and devastates crops. So I think that we really must figure out how we address the climate crisis and invest in community resilience to its impacts. And Dr. Diffenbaugh, I have a two-part question. I'll ask the whole thing. Based on your research, how have advancements in attribution science informed our understanding of climate change's role in extreme storms and precipitation? And the second part is, based on that understanding, how would limiting the global temperature rise to 1.5 degrees Celsius rather than 2 degrees limit flooding and extreme storm events for communities on floodplains like mine?
Thank you for that question. So I started my PhD in September of 2000 in the Y2K era, and at that point, the overwhelming response of the scientific community to questions about attribution of individual events to global warming was that that we can't attribute any individual event. That's not something that we're able to do scientifically. That was back 20 years ago. There's been a huge acceleration in our scientific, the ability to answer that question scientifically, and it's thanks in large part to investments in research by the federal government at national labs and at universities and outside of those institutions. And what we've learned is that, in fact, the global warming that's already happened is increasing the risk of individual events in many locations and for many different kinds of events. And here in the U.S., extreme heat, extreme precipitation, extreme wildfire weather conditions, extreme storm surge flooding during landfalling storms, the severity of droughts when low precipitation coincides with high temperature, which is much more likely now as a result of warming. These are some of the many areas where we have now clear confidence that the risks are already elevated, and in particular for unprecedented events. And this is really important, right? We now have clear understanding that we're already in a climate where we have substantially elevated probabilities of events that are more severe than any we've experienced or any that we've observed historically are now more likely. And so for the kinds of impacts on communities that you were describing, the lower the level of warming globally, the less intensification of these conditions will occur. And I want to note again that the impacts are nonlinear, right? Where in so many of these examples that you provided, for instance, in agriculture and in flooding losses, we see historically that the impacts are nonlinear with in some cases exponential impacts at higher levels of warming. So there's absolutely benefit to curbing the level of warming, and in addition, that adaptation gap again is so critical. And in particular for infrastructure, right? Infrastructure is really where we see the nexus of mitigation and adaptation, where we see the nexus of investment and community, benefits to communities. And so, updating our design, our operation of our management of infrastructure has great opportunities for both mitigation and adaptation in communities and for individual localities.
Well, thank you. I don't think I have enough time left to ask my next question. Madam Chair, I yield back. But thank you very much, Mr. Diffenbaugh.
Madam Chair, I believe every member present has asked questions.
Thank you very much, and thanks for all the participation. Before we bring this meeting to a close, I just need to ask if there's anyone with a hot question that they'd like to ask at this time. Hearing none, I'd like to thank our standing witnesses for participating today and testifying, and to notify you that the record will remain open for 2 weeks for additional statements from the members and for any additional questions the committee may ask of the witnesses. Our witnesses now are excused and our hearing is adjourned.